with your elements.
So, welcome everyone to MOMLET Data Science 2022. The MOMLET conference is started. Let us give a short welcome to everyone, and we will record this meeting and you can watch it. Also tell those who could not join yet that there will be presentations recorded and they can ask if they missed something. Modern machine learning technologies and data science is a third workshop, and it's hosted by Leiden Institute of Advanced Computer Science, Leiden University, the Netherlands, and in conjunction with Lviv National Polytechnical University in Lviv, Ukraine. And we have various partners, which are University Institute of Lisbon in Portugal, Computer Science at the Montfort University in UK, Politechnika Śląska in Poland, and Institut Galilée of University Paris in France. Also, we have sponsors, the Montfort University SoftServe Lviv IT Cluster and CNU Institute. And we would like to thank all of these people who helped us to establish this conference and conference series. Actually, this is the fourth edition of the MOMLET workshop, and previous editions were on-site or in a hybrid format in Ukraine, in Shatsk, which is a very beautiful place, and we hope in the future we are having the possibility to meet again in person in such a beautiful place in the Ukraine. And this year we have co-organized it. So before it was mainly organized by Lviv University, and this year it's co-organized with Leiden University in an online format. I would like to show our two universities briefly. So let's start with the Lviv Polytechnical University, and we have a short video clip. It takes a moment. Ta-ta. So this is Lviv Polytechnical University, and
With sound?
you can you hear the sound?
No. When you share screen, pick point system sound. Another screen.
Okay, we will change. 1 moment. Sorry for this little technical.
No problem. Once again, another screen. Yes.
I'm getting called by Skype. So I hope you enjoyed the presentation of Lviv University and Polytechnical. And we have also for Leiden a small video to discover Leiden University. So you're very welcome when you have opportunity to visit us. So this was the introduction to the two universities that host this workshop. And yeah, as I said, it's nice that we have the possibility to do it online. And we have also a nice set of invited speakers. Iryna Yevseyeva will give the first talk. And her keynote talk is about cybersecurity and multi-criteria decision-making. Dana Simian from Lucian Blaga University of Sibiu will talk about the machine learning SVM. And we have a talk on computer vision by Setiawan Hadi from the head of computer science department in Pajajaran University that is located in the second biggest city in Java, Bandung, which is known for the technology in Indonesia. So we are very happy to have them as invited speakers, and they will start the conference in this morning. And we have a number of session papers that went through a very thorough review. So we had an international jury, a program committee that peer-reviewed all submitted papers by means of the SIR workshop standards. So this is a quite strict standard for the quality of the papers. So everybody who will present today has proven that the quality of the paper is of a high standard. And we will present these papers and in this workshop, and then the full papers will be submitted to SIR workshop series for online publication. MOMLET is indexed by Scopus, DBLP, and Google Scholar. We are especially also proud to have a DBLP index for which the quality is to be achieved a very high standard, has to be achieved a very high standard. We have also a YouTube channel, so we will send to you the links. You can also find them on the MOMLET webpage that you probably all know, MOMLET in UA. So this is our webpage that has a link to the YouTube channel that contains also some videos of previous editions of the workshop. Today you received a program of the workshop, and in the program PDF you can click on the links that if you click on the titles of the presentations, you will see get the links to the YouTube videos that were pre-recorded before the conference. So you have a chance to watch videos to a later date. in case you are not able to watch them now. So we have this unfortunate situation of attacks on the electrical infrastructure in Ukraine, and many of the participants of the workshop can not join the full workshop or only join under extremely difficult circumstances. To accommodate for this difficult situation, we like to emphasize that we stick strictly to the time plan. This is not to make it difficult for the presenters, but to make it easy for those who can only join for a limited amount of time, for instance, because they have to charge some battery, and then they exactly at the time slot can present. So the times also pay attention to the time zone, whether they are in CET. I think we sent the program in Central European time, so that is 1 hour behind the Eastern European time. In like Kiev and Lviv is 1 hour ahead to Central European time. So please pay attention to the time zone, and pre-recorded video will be played if the speaker cannot make it. So in any case, there will be a presentation on the topic of the paper, and we will play the video if the speaker is not there. We cannot accommodate for giving the speech when you cannot be present, otherwise we could not plan the program. But be assured that we play the video, and there will be a question and answer possibilities in the coffee breaks and sessions. Please be so kind and try to also attend the coffee breaks and question and answer sessions if you want to ask questions to the authors of the papers. Otherwise, of course, it's possible to send them an email and ask some information. I think there is also I need to say that it's important to stick to the 15 minutes allotted to each paper, so that the schedule doesn't have to be changed. So we have to be on this strict to make it possible for everybody to stick to the time frame. For the case that we have electricity failure in Lviv, we have a second link from Leiden University created that is in the chat of the Zoom, and we will show this link in the chat of Zoom frequently during this conference, so that in case, please make a note for yourself for this link. You find it in the chat of Zoom. So I ask everybody who can make a local copy of this link from the Zoom chat. We should also, if the electricity breaks in Lviv, we can also send by email the same email by which you got the program. We will send this alternative Zoom link then. We didn't do it now because it might confuse people. Okay, and overall, we wish you, despite of these difficult circumstances, that we will have a very interesting MOMLET 2022 workshop. And this is in the name of myself, Michael Emmerich from Leiden University, in the name of Dmytro Dosyn from Lviv Polytechnical National University, and Victoria V. Storska from also Lviv Polytechnical National University, and the many people from the organizing committee who helped us to organize this conference. Having said this, I would like to start with the program, and let's have a very brief look at the program. We have still time to the first presentation. Let's have a look. So we have here the opening, which is now, and then we will start with the first keynote by Iryna Yevseyeva, and then we will have Setiawan Hadi's keynote and the keynote of Dana Simian from Romania. And we have then a coffee break, and in the afternoon we have the invited talks. This is the Eastern, this is the Central European time zone. So in you have to add 1 hour if you look at Kiev time zone, Eastern European time zone. Okay, so 11:20 we will have the first keynote, which is in 3 minutes. So I would like to now thank everybody for attending this opening, and I want to introduce our first keynote speakers and make sure that the connection is good. I think I got contacted right now. I will stop sharing. Let's see. I need to talk to the keynote speaker. She couldn't connect. I have to see what happened. I will send the link to our keynote speaker. She is probably not yet connected. I don't see her in the list, but she asked me via Skype. There was some problem. I will send an invitation. Invite, copy invite link.
Connected.
Can we see her?
Yeah.
Good.
Hello.
Hello, Iryna. Good to see you. Perhaps before I introduce you, I will. We will make sure that you can share the screen. Can you try share screen?
Yeah, just a second. Tasks for permissions. Okay, let's see if it works now. Doesn't allow me to share my screen.
Dmytro, can you check
Yeah,
permissions?
I check it. She has permission. Yeah.
Yeah, it's probably my own computer, which is which is,
green button below.
no, it's my own computer, which is very well protected from sharing stuff.
Protected.
Okay, Zoom, yes, I found, it's probably this one.
Security.
Yeah, it's about Zoom. But it asked me to leave meeting. Okay, let me leave it for a second.
So Iryna Yevseyeva is a professor for cybersecurity, so probably they are very well
Secure.
protected.
Very secure.
We will take the time.
I believe that most problem of security is human factor.
Mhm. It's a multi-factor.
Multi-factor. But Iryna will say it about this. It's
For sure. So maybe some permission still.
Hello? Can you
Hello,
see?
we can hear you.
So let's see if I can share now. Yeah, now it allows me to do it. So it was
Good.
reading restart. Yeah.
We can also hear you, so
Uh-huh.
all is good.
Good.
So I will briefly introduce you.
Yeah.
So Iryna Yevseyeva is senior lecturer at the University de Montfort in Leicester in UK. And there she is working on cybersecurity and multi-criteria decision-making, as you also see in this talk. And Iryna Yevseyeva has done in her career many worked in different places and has a lot of experience in mainly topics like multi-criteria optimization and also cybersecurity. And previously, she was a student in Kharkov Radio Electronics University, Kharkiv. And then she did another master in PhD under the supervision of Professor Kaisa Miettinen in Finland, in Jyväskylä University, and postdoc and industrial experience in Porto and in Lisbon and Faro, so all in Portugal. And also in Newcastle, England, in cybersecurity department, she was a lecturer. And now since some years already in the Montfort University in the cybersecurity department, working on combining machine learning, optimization, decision-making for cybersecurity systems. Thank you very much, Iryna, for giving us a talk to this conference.
Thank you, Mykhailo and Dmytro, for inviting me to give the talk. So I'm very pleased to do it. And I'm happy to see people interested also, not only in general machine learning optimization, but also in applications such as cybersecurity. So I will start with some questions to audience. What do you think are the main problems of cybersecurity?
So.
And yeah, the other question, how to solve them. Yeah, so if you think what would be the main issue, yeah. So you know, you can make analogy with defense. Yeah, so there is a generic defense, not cyber only, and you think what would be the main kind of issue there. Because you can map general defense to cyber defense.
I've already said people.
People? Uh-huh.
Yes, personal weakness. People.
So people are weakness. Okay, okay. Good.
Maybe internet, some information floating in this very intransparent networks.
Yes, yes. As soon as they say that, as soon as you connect to internet, you are not safe anymore. Yeah. So there is no kind of, the only 100% security you get only if you are completely disconnected. Yeah. So as soon as you connect it, you are not 100% protected. Yeah. So people are also an issue, because if people are secure, yeah, so if they behave in a secure way, it's also kind of level of protection. Yeah, so no matter how many levels of automatic protection you put into the system, if people behave insecurely, then you have some issue there. There are other obviously many problems, and it depends on with whom you are talking. People who work in different areas of cybersecurity will probably identify some different aspects. But also one of the aspects, and if you map it also to defense, and because we also have lots of Ukrainian colleagues, I thought it will be a good example, so that unless you attacked, you are not feeling any fear of and any, how to say, you don't feel vulnerable. Yeah. So after you have been attacked, now you feel, yes, I need to be protected. Now I need to build the defense. But before you've been attacked, you don't really care. Yeah. So you go on with the life, and and that's what most companies do. Yeah. So unless they have been really cyber attacked, they are not taking much care of defense, and that's a very big issue. So one of the problems is to convince companies to even take care of defense, and there are obviously lots of awareness companies and so on which are going on for organizations. And of course, when we talk about people inside organizations, we need to convince them to be secure. Okay, so how to solve these problems? Obviously, there are various ways, and in this presentation, I will talk just about few aspects of how we can help to take care of cybersecurity. And the two topics that I will cover is cybersecurity investment. So obviously how to convince board of directors to invest in security. So that's what I was meaning, that we have to convince them, people who are dealing with the company and taking care of the company, that security is important. And only after that they spend money on security. And the other aspect is talking about ordinary people, how to help them to make this more secure decisions. And that's what we call nudging. Yeah, so I will talk about this nudging approach, which is paternalistic, soft influence approach to help people to make better cybersecurity decisions. So the first part of my presentation will be about two-stage security control selection problem. So it's a joint work with people from various institutions. So we worked also with Mykhailo on this problem. The idea is that, as I said, if you convince somehow the board of directors to invest into security, then you need to select what is the best kind of, how much can I spend on security? And as at the beginning, we were talking about internet. As soon as you connect, you're not 100% secure, no matter how many protection measures you are using, simply because there is this kind of, there are always new attacks appearing. So obviously attackers are searching for new ways to attack your system. And this is a kind of a battle between attackers and defenders. So it's ongoing competition. Yeah. So anyway, we need to find a good amount of money which a company willing to spend and able to spend. And this amount of money should not be obviously should not be bigger than the profit of the company, because at the end you can spend everything on security and still be vulnerable. Yeah. So we have to find this optimal budget, And also we have to select how to distribute this budget between existing controls. And obviously currently the market is huge. There are various, let's say, providers of the same type of controls. If you think about antivirus company, they have plenty of controls, let's say, antivirus programs, yeah, but which one to choose? So, so we will look at that. So how to select controls, and how we will be doing it. So we will look at so-called portfolio selection problem, well known in financial world, and also we will map it to security portfolio selection. So as I mentioned, the main challenge, or at least in this work, one of these challenges is indicated as invest into security before even attack happens. Yeah, so we need to kind of predict possible attacks, check existing vulnerabilities, check existing threats, and kind of model what can happen. So it's kind of what if analysis to perform that analysis. Yeah, and then another challenge to convince, yeah, board of directors to invest into security before such attack happens. We have to minimize, if you think of that in security, no matter how much you invest, you can spend all your, as I said at the beginning, all your profit on security and still be vulnerable. So the idea is to spend as little as possible. Yeah, so we have limited budget, and that can be as a goal or as a constraint. Yeah, if it's think in terms of optimization, it can be formulated either as a goal or as a constraint, fixed one, or let's say varying one. And ideally, we want to protect against all possible attacks, but also against unseen attacks, which are called zero-day attack. So the attacks which have never happened, for which we don't know how to protect ourselves. And obviously, this is a huge challenge. We want to minimize expected losses, yeah, from all these potential attacks. And we want to compare, yeah, how we are doing, yeah, because we need some baseline. So if we don't spend anything on security, what is our damage? And then we will be looking at, okay, if we invest into this minimal level of security, how much we are kind of reducing this potential huge loss. Yeah, so that's the idea in this research, how we were looking at. If you try to think of cyber investment, so different people try to approach it differently. Yeah, but here we looked at it from this point of view. And as I said, we'll be looking at portfolio selection problem, well known in financial world. So if you heard of, if you ever went to bank and to invest your at least a little bit of money or save a little bit of money, you probably have heard of portfolio. So what is in financial world portfolio? So when they are trying to invest your money in the best way, they never invest it in a single asset. So as an example, you can think of, let's say when you say, I want to invest in energy, yeah? So they will be trying to invest not only in, let's say, oil, gas, but also in wind energy, yeah? So because wind energy is kind of alternative to this traditional, more, let's say, defined markets. So wind energy is more, let's say, non-traditional, and it would be, let's say, if all of them have to fail for some reason, let's say, in current situation, the example would be the oil and gas become very expensive, yeah? But what about wind energy? Does it also increase in price? Probably, but maybe not as much as oil and gas, yeah? So we can think of this kind of different assets which they are trying to put into the same portfolio. And here, that's how they're trying to, so the idea of this portfolio selection is to select such assets that will together maximize your return, expected return. Obviously, we are planning for future, that you, in some years, you will get this return from the money that you invested. And the idea of Markowitz, which got a Nobel Prize for his idea, was that you're not only maximizing the expected return, but you're also minimizing variance between those returns. And that's from the example that I gave, that the difference, let's say, between oil and gas is much smaller than between oil and wind, energy. So wind energy and oil energy will be much more different than oil and gas, because they are received in a different way. There are different kind of ways to supply it, and so on and so forth. So that was his kind of breaking through idea, so that he suggested that you are not only considering expected return, but also difference between these assets. And if you look at these two formula, the first one shows you expected return. So you have shares. So by X, we mean share. You can think of portfolio also as a cake. So you have a cake, and each asset is a slice of the cake. So you're taking this piece of the cake and you are projected it into the future. How much return this piece of cake will give me in the future. And then that will be your expected return. So sum of all of these pieces of cake multiplied by the expected return. And also as a second objective, you're taking a difference between the assets. So let's say you have taken the XY is your energy for oil and XJ is for wind. And you're checking how much they are changing over the time. So in this way, you will have a correlation between them. So you're checking their correlation and how much they vary along the time. So this is the idea of financial portfolio, which we will be mapping into the cybersecurity portfolio selection. So here, if we look at the traditional way, how cybersecurity risk is assessed, we need to look at the following. We need to understand all our potential vulnerabilities. So, for instance, if we are using a Windows operating system, what kind of known vulnerabilities are there? So let's say if you are using Microsoft Word or each of the, let's say, software assets, what are their vulnerabilities? And there is a list of known vulnerabilities. For instance, CVSS has even scores for each of the kind of assets that you are using. So you can go to this database of existing vulnerabilities and check if I'm using this type of software, hardware, networks, infrastructure, everything. So you can check against all these assets that you are as a company own. You can check their existing vulnerabilities, which is good to know. And of course, then you can plan which kind of controls I can apply. By controls, we mean protections. What kind of protection measures we can apply for them. Also, you need to understand threats. By threats, we mean potential attacks. So essentially what you are interested, how existing vulnerabilities can be utilized or exploited by attackers. And again, there are existing tools for evaluation of that. For instance, attacker tool by forgot the name of the company. So they produce a kind of matrix where you can check with existing, let's say, existing pathways for an attack happening. Cyber kill chain is one of the, let's say, map. So cyber kill chain developed by Martin Lockheed, and they kind of shown how the step-by-step attack can happen and what kind of exploitations can happen. So how each vulnerability exploited at each stage of this of this cyber kill chain process. So we know all the information about vulnerability, about threat. The last thing, we are interested in how to protect ourselves. And again, we can use existing maps, existing suggestions by various frameworks. So, for instance, NIST, it's American governmental suggestions how to protect your system. They have risk assessment frameworks, and they kind of developed a set of guidelines how to select controls. You can also think of SANS Institute in America, who are also developing a list of controls. They have lots of guidance how to select the controls for protecting the organization. Anyway, we know this information as well. So the idea is trying to be able to evaluate your losses. Yeah. So in this formula above, yeah, at the top, you see that we are trying to evaluate our potential losses. So we know our vulnerabilities. We know also impact. So if this vulnerability is exploited by this type of threat, what will be the impact, yeah, on the organization? And the most critical probably is probability evaluation. So how to evaluate probability of exploiting of exploitation. So if this vulnerability is exploited, yeah, via a certain threat, and I've talked about it can be even threat vector, yeah. So it's certain stages of attack. So what will be the probability, yeah, of such exploitation happening? Anyway, in case we have all this information, which sometimes will be difficult to get, we are able to evaluate our expected losses. Then we can compare this one if we apply controls. So if we introduce some defense measures, how much we can evaluate how much this loss will reduce. Yeah. So it's exactly the same part here, and then we are introducing by X controls and how these controls protect against certain vulnerability. Yeah. So we are doing lots of mappings, threats against vulnerabilities, controls against vulnerabilities. Yeah. And in this case, we know potential losses, and we know how much we can, let's say, reduce this loss if we introduce these controls. So obviously we might find the difference between this, and then we know how much the reduction of potential application of these potential controls. Yeah. And I've mentioned that we might have difficulties with getting information, but there are certain ways to find all the information. And here is just one example of potential, let's say, impact, how impact is evaluated. Yes, so we can measure impact by checking the three main properties of security are confidentiality, integrity, availability. So we can check the impact on each of these element of triage. Yeah. So and the total of this will show us total impact. Yeah. For instance, it just shows that partial protection, let's say, partial impact on confidentiality, partial impact on integrity, partial impact on availability. Yeah. And so on. For instance, obviously, if you have a complete protection, yeah, in all of these three dimensions, the impact will be, let's say, you are trying to kind of minimize impact. Yeah, so that's why you have you are dividing it. Yeah, so in this case, you will have let's say best value for the impact. Yeah, when you are protecting completely in all three dimensions, which is obviously not always happening, not often happening. So the same, we are talking about costs of control. So we usually have this cost of controls, because the idea is to select as spend as little as possible on controls. Yeah, so we have cost for controls, and here we have the other information on vulnerabilities. So we have a set of vulnerabilities and a set of threats, and how each threat affects each vulnerability. So for instance, if it's 0, it doesn't affect. If it's 1, it affects to the kind of in full. But you see, there are also negative. So this is how the control. So this is a set of controls, and this is a set of vulnerabilities. So it's information on how each control protects against each vulnerability, because we also have mapping from threats to vulnerabilities, but here is mapping from controls to vulnerabilities. So here you see that this control protects this vulnerability completely. Yeah. And this one, the 0 shows, so if it's 1, it protects completely. If it's 0, it doesn't protect at all. And if we have negative value, it means that it protects. So when we introduce this control, it also introduces additional vulnerability. Because again, what is control? It's a sum. If we think of software, it's a patch. Yeah. But sometimes when you patch something, it's a piece. Essentially, it's the piece of code which trying to let's say rewrite some bits of existing code. But again, with this new code, you might introduce additional vulnerability. Yeah, that's why there might be negative kind of values for controls protection. Anyways, just an example. And as I said here, there could be another. There should be another table with threats against vulnerabilities. So which would be showing how much each potential threat affects a vulnerability, and again we can get a value for it. So having all these values helps us to model our budget selection problem. So as I said, we have losses and potential protections. So our return, because at the end, if you think of return on investment, so you invest in financial terms, you invest some money and you expect to get a positive return at the end of 2 years, let's say, which might not always happen. Yeah, you know, if you are investing in a risky portfolio, you might get either a huge gain or huge loss as well. Yeah, you might get to that point. But the problem with cybersecurity is that no matter how much you invest, you will never get anything back. Yeah, essentially, you are just trying to not to lose, and that's why not to lose as much as possible, or let's say to lose as little as possible. Yeah. So here we are talking about return in terms of minimizing losses. Yeah, so that's why you see this formula. So you have loss minus the difference when you invest it into your controls. Yeah, so this value represents investment into the controls. And that's how you get your return. So the cost is easy. Yeah, so to compute, you have your controls, and each of them has some value for the control, how much it costs. Yeah, and here we have a risk, and here the risk is computed. Obviously, we have to take a bunch of controls. Yeah, in our case, portfolio will be portfolio of controls or defenses, and we are trying to select these controls in such a way that that they are protecting us in the best way. But when we think of in terms of, so I've mentioned threats, I've mentioned vulnerabilities and controls. So 3 main aspects. So we are trying to look at such controls, and you remember from financial portfolios that we are trying to find such controls that they are as different as possible or less similar, yeah, if we talk in other terms. So we are trying to diversify our portfolio of controls. And that's what this formula shows. So it tries to protect you against as many threats as possible. And it tries to also cover as many vulnerabilities as possible. And it also maps against, let's say, both threats, vulnerabilities at the same time. Yeah, and that they are not, let's say, the example would be you have control, let's say, antivirus. Yeah, it tries to protect you against viruses, but not only. Yeah, it does many other things. Yeah, so it's not only checking viruses, it's also checks, for instance, your web connections. Yeah, so it checks the files which you download. It checks the link websites which you visit. Yeah, so it does multiple things. If you think of firewall, it's in some sense it does the same thing, because it stops you from visiting some websites. Yeah, it stops you from downloading some type of files. So if you're trying to map these two controls against the same threats, you might end up with the same results. So which of the control do you need? Do you need a firewall, or do you need antivirus, or both? Yeah, and that's the answer we are trying to answer here by measuring how much these two controls are similar, against which potential threats they are protecting you, and so that we are selecting in the best way either both of them, one of them, or none, because there might be a third control. Yeah. So at the end, we are checking this, doing comparison of all to all. Yeah. So all controls to all, and in this way we will get kind of pairwise comparison of all of them. Yeah. So that's how we will get a risk. And of course, we are trying to minimize risk and have as little similarity between our controls as possible. So the idea would be we are simultaneously maximizing our expected return and minimizing our risk. Yeah. As I mentioned, the potential budget which you can spend in terms of investment, yeah, into security might be formulated as a constraint, budget constraint, or it can be another objective which can be also optimized. And another winner of the Nobel Prize, so I mentioned one, which was Markowitz, and the other one was Sharp, who developed this nice index, or again an economic index, which say that instead of optimizing these two objectives, which Markowitz proposed, yeah, for selecting the best portfolio, because at the end, as we all know from multi-objective optimization, the result is that you are, when you optimize two objectives or multiple objectives, you don't get a single optimal solution, but a set of Pareto optimal solutions. Yeah. And here that's the same. When we optimize these two objectives, we will get multiple optimal solutions. How to select one of them? Which would be the best trade-off between risk and return in this case? And that's what Sharp suggested. He suggested to take it as a ratio, yeah, between return and risk, and to maximize this ratio. So he proposed to optimize and find the ratio between those two objectives. So we did a simulation for our problem. And what we came up with was the two-stage control selection problem. So as I said, the budget can be an objective. And how to select the best budget can be an objective on its own. So what we were trying to do, we were trying to search where is this best, let's say, budget. Yeah, and you can see that you can. There are various ways how to compute it, but we were trying to, in the first stage, we were trying to find this best budget. And here you see again, we were computing Sharpe ratio, yeah? And you can see that the return might change, that the risk might change, but at some time you will get to this value, which is the best Sharpe ratio value. And here you see how that the simulation showed that there is this optimal value for ratio. So we were also looking at obviously how to find the best budget. And you will see that here you see this classical problem that no matter how much you invest, yeah, you will be able to spend more and more on security. So here you have different values for budget, yeah. But at some point, the return, or let's say Sharpe ratio, will not be changing anymore. So you are investing more, but your, let's say, additional gain is not changing that much, yeah. So you see that here is a sharp increase in your additional return on investment. So let's say you can think of also Sharpe ratio is for how much each, let's say, unit of return you are getting risk, yeah. So obviously it's about any ratio. So and here you see that this change is sharp at the beginning, but there is not much additional value in this part, yeah, of the graphic. So obviously our optimal budget should be somewhere here or here, yeah, or in between of these two. But obviously company might say, okay, we don't have that much, we are stopping much earlier, yeah. But obviously they shouldn't stop here or here. They should reach at least this point. At least that will be our suggestion for the company. So in conclusion to this part, and we'll see how much time I have left for the other one. I just want to say that we have shown this, and obviously this was starting at the very as a very theoretical research, but we have done much more things, much more practical things here. We were trying to find good data for like reliable data to modeling this problem, and we were talking to professionals in cybersecurity to get their feedback. What do they feel about it? And they could see a good, let's say, value for them, but still they are very, very suspicious. So it's a little bit difficult for us, and we've done even, let's say, commercial attempts to present it as a product, and we have developed a web page with a nice application even for mobile where you can use this nice system, but it's a little bit suspicious because you need to have a very reliable data, yeah. So, and you have to have the easiest information is to get cost of controls, but the problem is there are so many of them, yeah. So it's getting into the big data problem and how to compare them, how to find all the features of all these controls, like comparing two antiviruses, yeah. Finding probability of returns, yeah. So it's also how to say, computing all potential, mapping all potential threats to vulnerabilities, yeah. It's a challenging problem. Computing covariance, yeah, we need to compute covariance. Again, it depends on information about controls, how much we can compare them. Usually, yeah, this information is available from providers, but not always, yeah. So the outlook that this will be a way to help decision makers and board of directors of a company to understand the problem and to map it, yeah, into the threats, into attacks, and to, in this way, it's also one step towards helping organizations to, yeah, to start to invest into security, to understand their potential attacks. Yeah. And there are other challenges in this problem because currently we were solving it at the obviously it's NP hard problem. The more controls we have, the more difficult it's to get to solve. We can always apply meta heuristics, but how to make it more, let's say, exact, and that might be a challenge. Yeah? It's always a challenge in optimization problems. Okay, so that's so far that's the first part of my presentations. I don't know if we can stop here to ask questions. I
think we have 5 minutes left, so maybe we can you can just briefly say what the second part is about,
okay.
And give a link to the paper for people who are interested.
Yes,
and we can have questions for the first part.
Yes. So I have mentioned here the paper for this part. Yeah. For the second part, what we were trying to do, and this was also a large project which I did during my postdoc at Newcastle University, within a large project between two universities, Newcastle and Northumbria. We were working with psychologists. So the idea was we are trying to help people to make better security decisions. Yeah? And we were using so-called nudges, also well known in economics, in the social sciences, and in healthcare, where people are, you have seen also, I'm sure you have seen some signs or some nudges, visual ones, for instance, on the parking of next to the bikes parkings, you could see a sign, yeah, we are watching you, yeah. And this is just one example of a nudge, so that someone is looking at you. There are either sign of eyes, yeah, that are looking at you, or we are watching you, or things like that. So essentially they are nudging you against stealing the bike, yeah, so that you are under control. There is a camera. And so the same principles could be used in security. And this one is a little bit, let's say, frightening signs, but there are more, let's say they were using US government used to send a letter to people to say, all your neighbors have already paid taxes, but you. So it's a kind of social nudge, yeah. So trying to convince you to pay taxes just because others did it, yeah. And there are plenty of this kind of approaches that can be used, and we've done it for security. The additional bit, sorry. The additional bit on top of existing, let's say, ways to do the nudging, we were also, and I'm talking not about only security nudge, but which could be applied to other non-security nudging. So we were trying to model in a mathematical way how much influence is needed to change someone's behavior. So let's say, because obviously the more you push people, the more resistant they become. So from this whole project, which was 3 years project between two universities and multiple people working on it, the conclusion was that we cannot nudge all people in the same way. And mathematical model confirmed that some groups of people, if you push them, will behave counterproductively. Yeah? So we would have to really compute the amount of influence that we can apply to people, or let's say not apply, but apply or use for certain groups of people. So we first need to really study their behavior and understand how much doubting they have when they're making decisions, and how much we can force them to do something before we really even starting doing it. Yeah? Which was not the case in most of the research, because they say that it's one for all approach. So we have to use nudging in the same way to all people, and the overall result will be positive, even with some potential negative outcomes. We showed that it has to be done in an adaptive way, so it cannot be applied one to all. Yeah, we have to be selective. Okay, I will, there are some papers at the end of the presentation. Yes, so one was done for the conference, sorry. This was the journal paper, yeah, when we already had more, let's say, solid results. And the previous one was for the conference paper, which was here. Yeah. Okay. So I am happy to answer any questions if you have any.
Thank you very much, first of all, for this interesting talk. And looking at the schedule, I think we have time for a question or two before we start with the next talk, keynote. So are there people in the audience who want to ask a question? Please raise your hand. So maybe I have a question then. How would you say it is the best way to approach companies to apply cybersecurity, to convince them to pay more attention to this, and how should they nudge their people to apply safe passwords, etc.? So would there be some advice for us to be more safe and to company people or universities? So what is the main thing to pay attention for?
So in the UK, what they developed is there is this essential cyber essentials. Yeah, so there is this kind of program which trying to, let's say, show that security is essential to everyone. Yeah, and it's not only to, let's say, even companies. To it's more even towards individuals. Yeah, so. There are also other various programs. For instance, in the London Underground, you will see the signs, I mean, kind of advertisements and social advertisements for your sorry, I think I've switched this off. Just to switch because this meeting going on. So yes, they have the cyber essentials principles advertised in a London Underground. Yeah, so they're trying to put it in many places, and it's kind of simple guidelines. What we sorry, what we as individuals have to do. Yeah. So it's basic things like how to choose password, maybe using the simplest answer would be to use your password manager, yeah, and to have a single password for this password manager. Yeah. So you might hear such kind of advice. But it's not unique advice. Yeah, there might be kind of various ways to approach password collection. It depends also on people whether they want to remember this all the kind of various passwords or use one single password. Yeah, complex one. So it has, again, it has to be done in a slightly adaptive way because there is no single way for every person. Let's say I prefer to remember my passwords, but then there has to be a nice strategy for remembering. And imagine that someone discovered this strategy. Yeah. So then you have to change your strategy often. Yeah. So this kind of guidelines might be given, but it's again, some people say, no way. I want to remember one complex password for my password manager, yeah, and change it often enough, yeah. But one single password, not all of them.
Thank you. So looking at the clock, unfortunately, we need to move on because it is a very interesting discussion. We have maybe opportunity in one of the coffee breaks to talk about these topics. And I would like to thank again our speaker for an interesting talk. Let's
Thank
give
you.
some online applause and taking the time to prepare this talk and making us aware of this topic of cybersecurity, which I think is a very important topic where also machine learning and optimization plays a role to improve. And much practical advice. I would like to make the bridge to the next speaker. We have a kind of portfolio of topics in the keynotes. So the next speaker is a quite different topic. It's about computer vision. And I'm happy to introduce Setiawan Hadi from UNPAD. This is University Pajajaran in the it's in Indonesia on the island Java that many of you know, probably the programming language of Java, but also it's the biggest populated island in Indonesia. And it's the second city, Bandung, known for technological advanced city. And Setiawan works in various projects related to medical image processing, to image processing in terms of history, understanding letters on documents. He will talk about all this, and you will see an interesting talk how to interpret images with computers and various applications. He is also collaborating with Leiden University on these topics. We have joint PhD programs there. I will give, he is the head of the Department of Computer Science, University in Pajajaran. So it's also interesting maybe if you see this from the point of view of possible collaboration on image processing. Okay, I give the word to Setiawan Hadi. Thank you.
Thank you very much, Michael. Nice to meet you, everybody. Okay, let me share my screen. Okay, I think already I have seen the screen.
Yes, good.
Okay. Good morning, ladies and gentlemen, and maybe good afternoon for some people from Indonesia, my colleague. Thank you for inviting me to the organizing committee that's allowed me to talk about this presentation, especially for you, Michael, for allow me to talk in this conference. For the audience, welcome and nice to meet you in this workshop. I will present a talk entitled Modern Computer Vision for a Better Tomorrow. This is a more generic or general talks, not too detailed. I'm Setiawan Hadi from Universitas Pajajaran, Indonesia. Please enjoy my talk and I'm open to discuss. Let's begin. My presentation will be divided into 4 parts. In the first part, I will introduce vision and computer vision in general, including the history of computer vision. In the second part, I will present the current development of computer vision, including the main tasks and pipeline, and also implementation in industry and other areas. In the third part, I will talk about the future of computer vision based on the related technological development, such as cloud computing, high-speed GPU, CPU, and GPU, and also data availability. The last part, I will open the viewers to the benefit and advantages of using computer vision in daily life that can bring us a better living environment. Okay, I will introduce the vision and computer vision in general, including the history of computer vision in a short. Vision is a complex process. The human eye has many structures that contribute to the vision. Ciliary muscles change the shape of the lens to focus on both near and distant objects. The iris muscles control the size of the pupil depending on the lighting condition. The main refractive power in the eye comes from the cornea and the lens which allows light to be focused on the retina. While opening your eyes and taking in your surroundings may seem like a simple task, your brain is working hard actually during this complex process that we call sight. For example, why it is more difficult to see in the dark and many other intricacies of how the brain helps us see. The process of vision requires that light entering the eye be captured by sensors that convert into neural signals that can be sent to the brain. There, these neuronal messages are processed to general mental visual representation of the world. Digital cameras and human eyes fulfill largely the same function. Images come in through a lens and are focused into a light-sensitive surface, which converts them into electrical impulses that can be processed by the brain or a computer respectively. There are some differences, however. Human eyes, it has fovea, a very sensitive area in the center of their field of vision. It is responsible for sharp central vision, also called foveal vision, which is necessary for humans for activities for which visual detail is primary importance, such as reading and driving. The retina consists of rod cells and cone cells. The rods are responsible for vision at low light levels or scotopic vision. Cones are responsible for vision at higher light levels or photopic vision, such as sensing the color red, green, and blue or RGB light. However, in digital cameras, they have uniform sensitivity to light across their whole field of vision. Light's intensity and color are picked up by RGB sensors, elements on a silicon chip, but they aren't as good as capturing a wide range of light levels as our eyes are. Typically, a modern digital camera can automatically tune its exposure to either bright or dark scenes, but it might lose some detail. For example, when it is tuned for dark exposure or any bright objects might just like white blobs. Human vision and machine vision systems both contains two basic components. The first is a sensing device, and the second is interpreting device. In this talk, I will focus on machine vision or computer vision. Before proceeding, let's see some historical timeline of computer vision. During the late 50s, 1950s, and early 1960s, computer vision was mostly limited to image analysis to mimic human vision systems and see how much a computer can resemble that. One of the first breakthroughs came during the 1950s. It was in the form of neural networks to detect the edges of an object in an image. This approach made it possible to sort simple shapes into categories such as circles and squares. Later, during 1970s, commercially deployed computer vision algorithms could interpret types of handwritten text using optical character recognition. In the 1990s and 2000, large datasets of human images were made available online for analysis, thereby providing an impetus for facial recognition research. Accuracy rates of computer vision algorithms have also gone up significantly, starting with a mere 50% accuracy for object identification and classification. The techniques used today have shown near 99% accuracy within just a span of few decades. In the next slide, we will see the comparison between computer vision in the past and current computer vision processing. Computer vision in the past is, we know, is a basic mechanism for computer vision are first extracting the meaningful features from the raw pixels, then matching these features to known labeled ones to achieve recognition. Then researcher has to do a lot of work, was manually inspection and selection of features. For example, PCA, principal component analysis, was successfully applied to the first time to complex recognition problems, such as face classification. Another method appearing in the late 1990s, revolutionizing the domain, is called SIFT, Scale Invariant Feature Transform. But now, computer vision, we don't need to select the feature manually. Instead, the model can learn the feature from the image or the video, and it can process it and give output. Machine learning plays a crucial part in tackling image classification. Statistical ways were developed to discern images based on their features. SVMs, or support vector machines, were a long time the default solution for learning a mapping from complex structures to simple labels. The first convolutional neural networks, or CNN, was developed and applied to the recognition of characters with some success. The methods were computationally heavy or could not scale to grander problems. The computer vision community has adopted other machine learning algorithms over the years, including random forest, bag of words, Bayesian models, and neural networks. Now I will talk about the current development of computer vision, including the main tasks and pipeline, and also the implementation in industry and other areas. First, I will show you a picture. As humans, we can say that the picture is, however, it is not an easy task for the machine to describe what objects are in the picture. This is the foundation of why the computer vision field is hard to implement in the previous decade. But the purpose of computer vision is still the same, to get semantic information from images or videos. So, can you describe information about the image according to the arrow signs? Of course, I have already the answer. Well, how this image be processed by a machine and the machine shows information? This illustration brought us to generic definition of computer vision. So, computer vision is an interdisciplinary scientific field that deals with how computers can gain understanding what is being seen in digital images or videos. So the field of computer vision is changing rapidly at the moment because camera technology has been improving quickly over the last couple of decades. Not only is the resolution of cameras increasing, but they are also improving in other ways. They are more sensitive to low light conditions, have less noise, can operate in infrared, useful for detecting distances, and are getting very cheap. It's becoming reasonable to us to use multiple cameras, perhaps to give different angles or to get stereo vision. As mentioned before, vision systems basically are composed of two main components, sensing device and interpreting device. By sensing an image or a video, then processed by a machine, we hopefully get output that consists of information about the input or video. So, how the interpreting device works, in the next slide, I will show the pipeline of the computer vision process. Application of computer vision vary, but a typical vision systems use a similar sequence of distinct steps to process and analyze image data. These are referred as a vision pipeline. Many vision applications start off by acquiring images or data, then processing that data, performing some analysis and recognition steps, and finally making a prediction based on the extracted information. Before proceeding to the example implementation of this pipeline, let's apply above pipeline to an image classifier example. Let's apply the above pipeline to an image classifier example. Suppose we have an image of a motorcycle and we want to model the model to predict the probability of the object from the following classes, such as car, motorcycle, and dog. First, a computer receives visual input from an imaging device like a camera. This is typically captured as an image or sequence of images, forming a video. Each image is sent through some pre-processing steps whose purpose is to standardize each image. Common pre-processing steps such as grayscale, resizing, blurring, rotating, and many others are used for pre-processing tasks. Only by standardizing each image, for example, making them same size, can you then compare them and further analyze them in the same way. Next, we extract the feature or feature extraction. Features are what help us define certain object, and they are usually information about object shape or color. For example, some feature that distinguish the shape of a motorcycle, wheel, headlights, mudguard, and so on. The output of this process is a feature vector, which is a list of unique shapes that identify the object. Finally, these features are fed into a classification model. The step looks at the features vector from the previous step and predict the class of the image. Pretend that you are the classifier model, and let's go through the classification process. You look at the list of features in the vector feature one by one and try to define what is in the image. First, you see a feature of a wheel. Could this be a car, motorcycle, or a dog? Clearly, it isn't a dog because dogs don't have wheels, at least normal dogs, not robots. Then this could be an image of a car or a motorcycle. Then you move into the next feature, the headlights. It's a higher probability that this is a motorcycle than a usual car. The object has only two. The next feature is the rear mudguard. Again, there's a higher probability it is motorcycle. The object has only two wheels. This is closer to a motorcycle. And you keep going through all the features like the body, shape, pedal, etc. until you have created a better guess of the object in the image. So, this slide shows the computer vision tasks taken from Fei Li, Justin Johnson, and Serena Young's lecture 2017. Image segmentation is a processing technique that helps us separate an image into multiple parts called image objects, which can help us analyze the picture more simpler. This picture shows the difference between object detection, semantic, and instant segmentation visually. Image segmentation is different from object detection and image recognition. Image segmentation returns granular information about the contents of an image. Object detection, which localizes objects in an image by drawing a bounding box. Image recognition assigns multiple labels to an entire image. Semantic segmentation is a problem of a computer vision in which our task is to assign a class to each pixel in the image using that image as input. In the case semantic segmentation, we don't care if we have multiple instances such as objects of the same class. We simply label them all with their class. So the modern computer vision, we are going to talk about it with a modern advancement in artificial intelligence and computational power. Computer vision has become an integral part of everyday life. Before going on, let's take a look at something else. Computer vision is a big subset of artificial intelligence, which encapsulates a lot of different fields such as robotics, machine learning, which is also data science in a way than deep learning. Convolutional neural networks are a big part of computer vision. Modern computer vision uses machine learning algorithms, more specifically a neural network, to determine insights from this data. These neural networks extract patterns from samples working similar to human brains. Computers' ability to see and interpret the world around them helps in the analysis of the massive amounts of data created in daily operation. While traditional computer vision focus on finding features manually, modern computer vision applied statistics and probability for finding features automatically. Now I will explain some technology that becomes foundation of modern computer vision. ImageNet, CNN, AlexNet, and GAN, or General Adversability Neural Network. Okay, until 2005, we did not have a lot of data to create these algorithms or to tell them if they are working well. But in 2009, everything changed, as many US institutions and industry players came together to create a massive dataset called ImageNet. The dataset included close to thousands object classes, including airplane, automobile, bird, cat, deer, dog, frog, and so on. With this, the problem was solved. We had a massive dataset to identify whether the model is working or not. Citing the ImageNet Kaggle challenge, the error rate in the ImageNet challenge has reduced significantly over the years, thanks to the introduction of models like AlexNet, which reduced the error rate by 16% in 2012, followed by Zeller and Fergus for 12%, Visual Geometry Group or VGG for 7.3%, and others. So the error rate is decreasing. So in 2012 onwards, people started using convolutional neural networks or CNNs and did some adjustment that reduced the error significantly. Before this, people relied on shallow neural networks where the error rate was close to 3%. CNN is the foundation for modern computer vision. Generally, it consists of input layer, convolutional layer, pooling layer, fully connected layer, softmax, logistic layer, and output layer. This picture illustrates small processes involved in CNN. I think you have already known about these pictures. AlexNet was one of the first key models to become popular in computer vision. To explain the science behind AlexNet from the basics, it is essential to know two key concepts: convolutional neural network and pooling on an image. The fundamental concept here is that you have filter which is similar than the size, which is smaller than the size of the image, and you slide the filter across the image at every point of time across the pixel. That creates an output of the convolution. Once you have convolution, you can use multiple filters to create multiple outputs. AlexNet contains close to 8 layers of convolution and pooling filters, as shown below, 5 convolution layers and 3 fully connected layers, which help identify the objects. On the other hand, a model like ResNet has about 152 layers to successfully identify or make sense of the object. GAN, or Generative Adversarial Network, is a class of machine learning framework, also popular application of computer vision. Designed by Ian Goodfellow and his colleagues in 2014, compared to neural networks like ResNet or AlexNet, which try to understand the image, GAN creates an image that doesn't exist. Two different neural networks are working here. They are working against each other. One network consists of real images, while the other consists of fake images created by the generator model. It includes a discriminator, which learns from the real image and compares the real image with fake images. Once you repeat this process several times, you can run multiple epochs, forward, backward, passes, etc. After a point of time, the generator starts creating really good images which look very realistic, and the discriminator can only be able to identify if the image is real or fakes. One of the popular applications of GAN is deepfakes. Deepfakes are synthetic media in which a person in an existing video or image is replaced by someone else's likeness. Alexander Emmerich, on the left, and his colleagues at MIT and Harvard University have developed neural networks to model synthesized celebrities. This slide shows the deepfake video of former US President Barack Obama, which Emmerich unveiled at his introductory course on deep learning in 2020. The future of GANs look bright. There are several areas in which it can be used, particularly in creating infographics from the text, website designs, data compression, drug discovery, and development, generating text, music, art, and so on. So we have a question: what computer vision can do? You may be familiar with all these snapshots of Instagram filters. That is a form of computer vision because they are actually using your input image and then running a model over it to transform the image. You can see the different age of the person. We can change it using computer vision. Another thing is optical character recognition, which many of you would have seen if you have scanned document, and then it automatically can recognize the text in those documents. License plate reading is another form of OCR, such as for self-driving cars. Self-driving cars, they are not in the marketplace yet. Although Tesla does have some that do like reverse parking and a bunch of highway cool stuff. Another computer vision can do is in sporting analysis. There are analysis of action called action recognition is one of computer vision can do. For example, in a football game, analysis of how a football player kicks a ball is an interesting activity that can be analyzed by computer vision. You probably would have seen some of these things that how football player act in football game. It also tracks the ball and tells you where it's going to end, including tracking the player. And last but not least, this is quite interesting until now. Facial recognition is a way of identifying or conforming an individual identity using their face. Facial recognition systems can be used to identify people in photos, videos, or anything in real time. You would have actually seen and used a lot of things, as I mentioned before, but there is another application that computer vision can do in the military, in the manufacturing industry, in healthcare, also in automotive and driverless vehicles, and many more. So computer vision can see so we can see that computer vision applications are endless. So it makes the future of computer vision very bright. Computer vision is a rapidly growing field in research and applications. Advances in computer vision research are now more directly and immediately applicable to the commercial world. An increased need of automation and a growing demand for vision-guided robotics and other industry-specific systems are driving the massive adoption of computer vision application. In terms of financial things, the market is expected to grow from around 10.9 billion in 2019 to 17 billion by 2024. Students with skills in computer vision and machine vision are learning snapped up by companies even before they are close to graduation. So for computer vision, the present is bright, the present is bright and the future is even brighter. So computer vision in the future will perform a broader range of function. Not only computer vision technology be easier to train, but also be able to discern more from images than they do now. This also can be used in conjunction with other technologies or other subsets of AI to build more potent application. For instance, image captioning application can be combined with natural language generation to interpret the objects in the surroundings for visually challenged people. Computer vision will also play a vital role in the development of artificial generally intelligent or AGI and artificial super intelligent or SI by giving them ability to process information as well as or even better than the human visual system. Considering the capabilities of present-day computer vision, it might be hard to believe that there are more benefits and application of the technology that remains unexplored. The future computer vision will pave the way for artificial intelligence systems that are human as us. However, before doing so, there are few challenges that must be overcome, the biggest of them being the demystification of the black box of AI. That's because just like other deep learning application, computer vision, while being functionally effective, is undecipherable when it comes to its inner working. So the core technology of the future vision, the field of computer vision is rapidly transforming industries like automotive, healthcare, and robotics, and it can be difficult to stay up to date on the latest discoveries, trends, and advancement. The core technology that influencing and will continue to shape the future of computer vision development in 2022 and beyond are cloud computing, services that help scale deep learning solution. And then automated machine learning solution reduce the repetitive work required in standard machine learning pipeline. Next, transformer architectures developed by researchers to optimize computer vision tasks, and mobile devices incorporating computer vision technology. We'll see all these aspects. Cloud computing solution. Cloud computing provides data storage applications, servers, networks, and other computer system infrastructure to individuals or businesses over the internet. Cloud computing solution offer quick, cost-effective, and scalable on-demand resources. Storage and high processing power are required for most machine learning solutions. The early phase development of dataset management often requires cloud computing resources for storage or access solution application like BigQuery, Hadoop, or Bigtail. GPU availability has accelerated computer vision solutions. However, GPUs alone aren't always enough to provide the scalability and uptime required by these applications, especially when servicing thousands or even millions of customers. Cloud computing provides the needed resources to start up and supplement existing on-premises infrastructure gaps. Cloud computing platforms including, Amazon Web Service, Cloud, Google Cloud components of the machine learning and data science project pipeline, including data aggregation, model implementation, deployment, and monitoring. For computer vision developers, designing vision systems is important to be aware of these major cloud service providers' strengths and how they can be configured to meet specific and complex pipeline needs. Machine learning has achieved considerable success in recent years, and if ever-growing numbers of disciplines rely on it. However, this success crucially relies on human machine learning experts to perform manual tasks. As complexity of this task is often beyond non-machine learning experts, the rapid growth of machine learning application has created a demand for off-the-shelf machine learning methods that can be used easily and without expert knowledge. It's called automatic machine learning. So AutoML will make machine learning more accessible, improve the efficiency of machine learning systems, accelerate research and AI application development. So this is what we call automatic machine learning. Deep learning methods have long been used to tackle computer vision challenges. Neural networks, architectures for face detection, lane detection, and pose estimation, for example, all use deep consecutive layers of CNN. New architecture for deep learning algorithm is emerging. It's called transformers. The transformer is a deep learning architecture introduced in Attention is All You Need paper. The paper methodology creates a computational representation of data by using attention mechanism to derive the significance of one part of the input data relative to other segments of the input data. Transformers have made a considerable impact with the NLP domain with generative pre-trained transformer called GPT and bidirectional encoder representation from transformer or BERT. The transformer does not use the convention of CNN, but research has shown the application of transformer models in vision-related tasks. There is a vision transformer, which is called, there is transformer for vision application, which is called vision transformer. So the vision transformers is a major breakthrough that emerged during the past year. It was the inclusion of new neural network topologies within computer vision. These new topologies have revolutionized the conventional way convolutional neural networks are used to solve typical computer vision tasks such as classification, object detection, and image segmentation. The eruption of transformers in the field of computer vision significantly improve the ability of these topologies to extract image features and thus improving the hit rate in the respective ImageNet benchmark. So now I will show you the nodes of computer vision in the future. We should validate computer vision model design to ensure models work correctly with specific real-world application of computer vision. Organizations looking to adopt computer vision technology or enhance their current implementation should concentrate on the insights they want to gain. We can deliver better quality insights faster and at scale. We should focus on the specific outcomes they want to achieve. We should also monitor computer vision to ensure safety, reliability, privacy, and morality. Ethics framework can be a starting point to consider. So, we talk about modern living with computer vision. This is the last part of my talk. In the world today, generally speaking, people cannot live without technologies such as televisions, mobile phones, computers, and others. These technologies have slowly taken an essential part in people's day-to-day lives, and being without them would be unimaginable for some of us. As I previously described, computer vision technology is also part of our daily living, not only now, but also next in the future as part of modern daily livings. How computer vision can help us to a better tomorrow? The general sampling is the development of smart cities. A smart city uses information or communication technology to improve operational efficiency, share information with the public, and provide a better quality of government service and citizen welfare. The main goal of a smart city is to optimize city function and promote economic growth, with also improving the quality of life for citizens by using smart technologies and data analysis. The value lies in how this technology is used rather than how much technology is available. A city Smartness is determined using a set of characteristics, including an infrastructure based on technology, environmental initiatives, practical and high. I'm sorry?
No, please.
Okay. Confident and progressive city plans. People are able to live and work within the city using its resources. The success of smart city relies on the relationship between the public and private sectors, as much of the work to create the maintain a data-driven environment falls outside the local government's remit. For example, smart surveillance cameras may need input and technology from several companies. So, computer vision, there are some implementation of computer vision for modern living. First is environment and energy. The use of machine learning in smart city makes it possible, above all, to control pollution by detecting, for example, CO2 emissions. Other air pollution prediction tools can inform authorities on decisions about reducing pollutant use. Sanitation and waste management, setting up an urban infrastructure made up of AI-powered robots allows a smart city to improve waste management. This ranges from sorting and recycling waste to cleaning the areas concerned, such as lakes, rivers, and so on. Transport. Some cities use a fleet of vehicles like buses or garbage trucks that can scan streets using camera and sensors. This makes it possible to create a 3D map of the city. This information can be used for maintenance, improvement, parking, and so on. Traffic. For traffic, the AI infrastructures in a smart city is mainly based on computer vision. This means the city is leveraging visual data to manage traffic. The simplest way is, for example, to place cameras in the city to identify areas of congestion in order to reduce traffic and accidents. Security. Another way to harness AI in smart cities is also through security. To do this, authorities use public data to identify criminals and monitor suspicious behavior. Suicide prevention in public spaces. Camera systems can also be used to implement suicide prevention system in public spaces by analyzing visual features like typical body language movement and recognizing unusual behavior. CCTV cameras with deep learning smart city applications can be used for assessing crisis behavior at suicide hotspots such as bus station. The main goal is the development of automated detection systems for early intervention that can potentially save lives. Smart water management. A smart world also includes the smart use of our most precious resource, water. In modern processing plants, not only water, but also large amounts of data are processed. Our smart water solution use this information and help improve water supply, disposal, and use. Connecting and evaluating different data enables safe and efficient monitoring and control of complex and critical information based on events. And finally, smart buildings. Self-optimization of buildings is part of smart city. Smart buildings are an important aspect of smart cities if they are intelligently networked and integrated into the overall concept. Building can contribute to the development of an efficient, stable, and profitable urban concept. So, computer vision for a better tomorrow. So, what role of computer vision? Computer vision technology has become more widely available, or making it more tempting to business in other areas.
Такую штуку там в кухне уронил на полу.
Once again,
So computer vision technology has become more widely available. Computer vision is not just only about replacing human worker. In the 1950s, there's question if a machine could think like humans. Now it become a reality. The big question is, will computer vision make human workers obsolete? In the field of medicine, computer vision is not just improving efficiency, it's saving lives. AI technology helping retailers improve customer service and create a personalized shopping experience. The agricultural industry has made a sharp shift toward high-tech, increasing all-round productivity by utilizing AI. Computer vision is now even surpassing human capabilities, increasing from 50% accuracy to 99% accuracy. So computer vision can perform tasks humans have not traditionally been able to. In the technical algorithm things, since the inception of modern computer vision methods, success in the application of these techniques could only be seen in the supervised domain. Human supervision use is necessary in order to make model useful for performing tasks such as image recognition, object detection, and or semantic segmentation. However, new technology has revolutionized the paradigm of computer vision. In major shift, computer vision research has changed the focus of the field away from the guaranteed success with human supervision onto new frontiers, self-supervised and unsupervised learning. Today, computer vision is one of the major technological advances in our recent history. Combined with artificial intelligence and machine learning systems, computer vision is essential for companies that want to evolve into so-called Industry 4.0 into 5.0. What impact does this technological advance have on what will be the day-to-day life in our company? Several industries such as logistics, food, textiles, or automobiles currently use computer vision in many of their processes. For example, in the logistic and transport of raw materials, the use computer vision allows, among other things, the recognition of objects as well as control the verification of cargo transport and so on. So, computer vision.
Setiawan, we to have time for questions, we should try to.
Okay, I will end this presentation. Computer vision is one of the most widely adopted technologies. It is used at least 20% companies worldwide. Okay, I will come to the end of the presentation. Well, computer vision is a technology we are facing today and tomorrow. As technology, it should make people happy. In terms of happiness, technology has made business much easier and faster. Technology makes it possible for sellers to exhibit much more products and services, contacting friends and family. Technology changed the educational system in various ways. Well, we come to the end of presentation. Sorry for passing the time limit. Thank you very much for your attention. Thank you.
Thank you very much for this interesting talk. I think it was a great and exciting overview of the history and also the future of computer vision and the technologies. So you did a great favor to our audience with this talk to update us on these new trends and a vision for tomorrow. Are there any questions for the from the audience on this talk? Maybe we have time for a short question.
I have one philosophical, maybe some question. Today, computer vision only classify objects, but how is such association memory? Real human not only classify images, but also remind himself something connected in association. What do you think?
Okay, thank you, Dmytro. It's quite interesting because computer vision is a technology that tries to mimic human, how human sees, how human probably in the next decade will be how human thinks. So it can make a decision. So there is research about the brain memory that process the information from the input. For example, in my talk is about the vision, and then process the input images in the brain. And in this case, brain is computers actually. So it's use knowledge-based memory. Not we call it, yeah, as you said before, that it's associative memory that can associate everything and dig the previous information in the brain and then give the information. As for example, I just met with Dmytro. So maybe next time when we meet again in some place someday in conference, oh, I know Dmytro, or maybe you as well will meet me in other
Thank you.
event. Yes.
So I think we are a bit over time. I don't want to be impolite, but we have a chance. So Professor Hadi agreed to be part of the panel discussion tomorrow, and you have another chance to ask him questions there and or give comments. And I would like to thank again, and let's give an online applause to this great presentation. So let's hope to meet you again in another conference or setting. And I want to make the bridge to our next invited speaker, a keynote speaker, Dana Simian. And she is one of the leading professors in information systems and computer science in Romania and works in the Sibiu Lucian Braga University, that is one also of the main universities in Romania. And she will today talk about a core topic of MOMLET, which is related to machine learning support vector machines. And I'm very happy that you agreed to give us a talk. And I should not leave unmentioned that you also organize many interesting conferences in Sibiu that might be of interest for the audience here. So feel free to contact us about this and make us informed about this. So we happily participated in some of them recently. So the word is to Dana Simian.
Okay. Thank you very much. Do you see my screen?
Yes.
It's
yes.
okay. Yeah.
Yes.
Okay. I would like to thank you for the invitation to participate to this online conference, and I really hope that I will have the chance to participate to a real physical conference together with the colleagues from Ukraine and Holland and the other colleagues. I'm pleased to be here and to hear a lot of very interesting topics in the artificial intelligence and machine learning. As Professor Emmerich said, I am a professor at the Lucian Blaga University of Sibiu, Romania, and director of the research center in the informatics and information technology. And one of the most important field we are working in is the field of modeling and developing of intelligent systems. As we have also a conference. Thank you for reminding this conference to all the participants. The title of the conference practically refer to some techniques that we propose in order to make the model selection in the case of support vector machines and support vector regression. But of course, these techniques could be generalized for other one. Of course, we started in this field of machine learning, this talk, because is a current field that not only construct the mapping on the input to the output starting from the data. There are a lot of other new topics in the field including also explainable machine learning. But anyway, in the case of supervised learning, classification, and regression, we focused on model selection. And practically, we are situated in the right part of the flow of solving a problem using machine learning techniques. That means building the candidate model before deploying and obtaining an optimization in his candidate model. Practically, we have some issues in applying machine learning to solving a different problem. And one of the biggest issue is, of course, the no free lunch theorem that govern machine learning field as well as optimization field. And this theorem states that practically in average, the results or the performance of all the algorithms on the set of all problems is the same, meaning that we cannot find a model to be the best for all problems. So we need to choose our technique, our method, and then to compare with other existing models. So we cannot work only with one model. On the other part, the model are dependent of a lot of parameters, and we should choose these parameters before deploying our model. Yeah, I think there is a microphone that is open that maybe should be closed. Dmytro? Okay, so this talk practically take into account the tuning of the hyperparameters in the case of support vector machines. And we choose this method because for some problem that we are working with was a method proving good results. So practically support vector machines are supervised learning methods introduced first by Vapnik for the linear case of the problems. Of course, we are now in the field of supervised learning, so we need data in order to train our model. We have the features and the labels in this training set. And we aim to obtain a decision function. And in the case of the support vector machines, practically this separated hyperplane is the hyperplane that best separates the class, such that minimizing the error. So practically, you can see here a bivariate problem that is solved using support vector machine. We just construct or build hyperplane, a linear hyperplane that separate our two classes such that the distance between classes be maximized, and this will lead to a less number or optimize the number of the errors. What is important is the presence of these two extreme hyperplane that delimitate this tube, and instances that are situated on these hyperplanes are named support vectors, and only these support vectors contribute to practically the classification. So we will work with some special hyperplanes with maximum gamma margin in the case of our problem. And we have here to determine W, that is practically the normal, and B, that is the distance from the hyperplane to the origin. It is known that practically this problem can be formulated and a classical quadratic optimization problem with constraints, and what we have to maximize is the tube that separate our classes, and these can be expressed in maximizing the quotient between 2 and the norm of W, having the constraints written here that assure that our classification is correct. The labels I are -1 and 1 for the two classes. So practically what we have is the sign of a new point related to the hyperplane that make the separation. So I will not insist on the optimization problem because it's probably known. We use a Lagrangian function and then formulate the dual problem such that finally we obtain the expression of our separating hyperplane F in terms of the Lagrangian, the label, and what is very important, the inner products between two instances, the unknown instance, and practically not all, but the support vector instance, the support vectors from our problem. This is the case, initial case of the linear separable problem, but the real problems are more complex, so they are not linearly separable. And then we have the soft hyperplane, soft classification, allowing a few errors, so a few elements to enter inside this separating tube. And we have another problem, a problem of soft margin hyperplane, where the function that we optimize has a parameter C, a very important parameters that represent a trend off between the error between the tube, how large this separating tube is and how much we can allow the elements to enter inside. So we obtain here one first parameter that must be choose or tune before starting building a model using these support vector machine techniques. But in the case when the problem is strong or non-separable, we cannot apply this soft method. So one possible method is to build a map or to find a map that transform our initial instances in a space with higher dimension in which practically the points will be linearly separable. So we will have two spaces, an initial input space and a feature space with more dimension, allowing us to solve the problem in a linear way. It's the same case for this problem when we want to find a function such that to obtain the linearly separable problem. So how to find this function? So the answer is very hard, or maybe we cannot find it. So we need to find other solutions to solve this non-linear problem. And the solution relies on the observation that in the express of our classifier, we have only inner products and not the instances itself. So practically, if you write here again, the equation, we will have the labels, the Lagrangian, and the inner product between the mapping that is unknown of applied to x, I, and x. So in this case, we apply the so-named kernel trick. So we suppose that practically this inner product is obtained using a kernel function. So probably you know that these kernel functions are function with special property that can be expressed and inner product between two elements. So instead of trying to find phi, we will try to find suitable kernel here. So we have another hyperparameter, very important, how to choose this kernel. So we choose this kernel using the observation that other researcher made about the kernel used for different kind of data, or trying different kernels, but we have some known kernels, simple kernels. So the linear kernel, the polynomial kernel, it can appear with a coefficient gamma here, or with 1 here, with a coefficient r here, or with 1 here, and only with d. We have the RBF kernel, the sigmoid kernel. So a lot of kernels that are hyperparameters. We need to choose the best kernel, and for one of these kernel, we have to choose another parameters. So the number of hyperparameters increases. The problem is more complicated because the real problem are more complex, and it is not sufficient to use for solving our problem a simple kernel. So we can try all the known simple kernel and to not obtain good results. So what to do in this case is to try to make a more complex kernel. So in order to obtain this kind of more complex kernel, we have the Mercer theorems and the known fact that using operation addition, multiplying, and exponential apply to the set of all kernels, we obtain also a kernel. So we can make this kind of combination. But here it's again a kind of uncertainty, how to combine this kernel such that to be good for my problem. There were different attempts using a linear combination of kernels and optimizing the coefficient, or using evolutionary methods. So practically resuming, we have a very important parameter C, and this parameter can be also with another one depending on the type of the support vector machine, or in the case of support vector regression, we have the kernel type, we have the kernel parameters. We can choose them just like this. Let's try one parameter, it is good or not, or let's try the experience of other and make a grid search cross-validation in order to optimize our problem. What we want to present here, it's a hybrid method that uses genetic algorithm and swarm-based, sub-intelligent-based algorithm, more specifically worm behavior based algorithm, in order to optimize practically the complex kernel that we use in our problem. The solution is structured in two levels. We have a macro level when the genetic algorithm will compute the optimal kernel. But for our algorithm, we need a fitness function. And this fitness function is computed in a micro level. And we can use this fitness function to evaluate the quality of our chromosome. But of course, we have here the question how to encode the information regarding our kernel in the genes of our chromosome. And for this, first, we sought to our multiple kernel like a structure of tree. So let's suppose that we have 4 kernels that we want to compose. We can use maximum 3 operation to obtain complex kernel, and this can be described as a tree. So in the nodes of the tree, we have the kernel, and in the intermediate, in the terminal nodes, in the leaves, we have the kernels, and in the intermediate node, we have the operation. So our composed kernel will be the kernel 1 operated by means of operate 2 with kernel 2. These will be composed using the operation 1 with the composition of key 3 and key 4 using operation 3. Here it's another example. In the case in which we have exponential, we will have only 3 kernels here. Of course, this 3 representation is only a formal one because we need a linear representation in order to have a chromosome. First, we thought to a simple problem. If we only use polynomial kernels and compose, then we will have just 4 coefficient D1, D2, D3, D4 for the 4 kernels that represent the power of the exponential of our polynomial kernels, and all the polynomial kernels will have the same value of R. But more generalizing more the problem, for any kind of kernels, we need to have the type of the kernels. If the kernel is polynomial, we will have the parameters D and R. They are stored using 12 and 4 bytes, and in the other, or genes, and in the other case, we have a real one that need a 16 value for 16 genes for storing. So totally for our composed kernel, 78 genes. We try to, or implemented our method only for 4 kernels, but we also make studies in the case of support vector regression to see the influence of the number of kernels, so to make a sensitivity study. And we obtained that practically 4 is the best number of kernel reported to the accuracy. If we increase the number of kernels, the accuracy, by example, to 16, the accuracy will be a little more, but just a little, and the computational time is more bigger than in the case of 4 kernels. So this 4 is practically somehow optimal value for composing our multiple kernel. In the genetic algorithm, it's very important to see what operation do we use. Of course, we have the exploitation and the exploration problems. The exploitation are obtained by crossover operation between solution, and the exploration, that is very important, is obtained using mutation operators. We choose 3 types of mutation operator. The classical one, a commutation operator introduced by the Falco that works on strings of bits, and another commutation operator that was introduced by one of my colleagues, Florin Stoica, in his doctoral thesis, is named left-right commutation operation, and generalized the Falco commutation operation by looking for the longest string of genes situated at the left and at the right of a given gene, that is means a random considered genes, such that we change longest string of elements. It's important because the information that is enclosed in these adjacent genes can be in this way transported to the other chromosomes. If we have time, we will enter more in details at the end of the presentation of how these mutation work. What we wanted also to make is to improve our genetic algorithm using some meta heuristics. And here we refer to our codification. If we look here, we need 2 genes for codifying the operation. We just map the operation on the set 1, 2, 3. Also, we have the type and many genes for the coefficient. That means that the probability that evolving our genetic algorithm to obtain more complex kernel using different type of operation is less than just modifying some coefficient of already existed simple kernels in our chromosome. That's why we want to increase the probability of changing the operation in the case of our chromosome. And for this, we use the WASP-based behavior model. So in the real life, practically, in the WASP nest, there is an interaction between nest and the environment. And this interaction practically is very interesting by the point of view of agents-based solving problems or solution for problems, and also for problems that can be modulated like scheduling of tasks in a factory problems. So what happens in the WASP nest? There is a stimulus and a response mechanism governing the way in which each WASP is engaging in feeding brood located in one zone of the nest. For each zone, there are response thresholds. For WASP and brood located in different zone broadcast a stimulus. So practically, these stimulus response mechanism will decide if a WASP will be engaged in this feeding process. So a loss response of the threshold will need a higher stimulus from the brood in order to make the WASP to be engaged in this action. But more, if 2 WASP are engaged in the same task, will be an interaction between them. And there is an hierarchy in the WASP that decides which WASP will be engaged. In the term of computation, we will have practically a probability function which will decide which WASP will be engaged in this task, depending of different elements. So what we want, we will associate to each operation will have associated artificial WASP, and WASP will have defined a threshold, and practically the operation will broadcast a stimulus. Of course, all of these are values of variables. What is important in this problem is how we will update in time the elements that contribute to the problem solving. That means the threshold is the most important element. The threshold can be remain fixed over time, or can decreases during the period time, or can have different formula for variation. What we decided, we defined practically the stimulus that is associated to each operation as a value constant that is 100% minus the accuracy of the chromosome. And we defined a function that is the probability that the mutation operator apply to a chromosome to perform a mutation that will change an operation that is coding with this chromosome. This probability depends on the threshold. This is practically the threshold. Initially, it can be chosen in a random way, and this is the value of the stimulus. The expression is taken from the literature or the research studies that have already made in the field of WASP behavior. So we decided to update our threshold in the sense that if the classification accuracy of the new chromosome is lower than in the previous steps, so we need to change practically the operation, and the probability will be increased by decreasing the denominator. And it's the same in the case when the accuracy is greater. In order to apply our method, we need to split the data that we have in 3 parts. We need a bigger part to say for obtaining the optimal kernel, and for this we need a subset for learning and a subset for validation. And after the genetic algorithm provide the optimal solution, the optimal kernel, we use the third subset to test our model and to evaluate our model. Evaluation is made using cross-validation and a 10-fold cross-validation. The implementation was made in Java, starting from the lib7 library. We just modify some classes in order to build our new multiple kernel. And we use different given set in order to compare our results. Here are presented the results from the leukemia dataset and for Vovella dataset. We can see that the classification is different in these 2 cases, and we have here the parameter of our optimal kernel. Here we compose 3 different types of kernel: polynomial, RGB, and sigmoidal, using 3 operations. And here, practically because we have exponential, and here we have 4 kernels and 3 operations, 2 sigmoidal and 2 polynomial. This was the method in the case of classification. Starting from this, we consider the problem of regression. So the output is not a discrete value, it's a real value. We have a regression problem, and we wanted to see how we can modify our proposed method such that to obtain the results that we desire. So the difference is that we cannot use the accuracy as a fitness function in the case of our algorithm. We cannot use, or it's not very good to be used, the genetic algorithm. We will replace it. And also the formulation of a problem, it's a little bit different in this case. So in order to define the accuracy, we can use different metrics, mean square error or root mean square error, absolute error, mean absolute percentage error. In order to solve our problem, practically we need to minimize the regularized risk. And this is defined also like the norm of W, this W that is the normal to our separating hyperplane. again, the constant C that is very important, and a loss function that is an epsilon insensitive loss function. And the problem formulation is given here. We have to minimize practically this function having the constraints imposed here. So more than C, we also have the parameter epsilon. And of course, we have to construct multiple kernels such that to be optimum for our problem. In this case, we consider the optimization not only of the multiple kernels, like in the case of classification, but also of the parameters C and epsilon. And instead of genetic algorithm, we will use a breeder genetic algorithm in which each gene practically store a real value. So in this case, again, for 4 kernels and 3 operations, for each kernel, so we will have the type, the parameter D and R if the type is polynomial, and the parameter gamma if it is not polynomial. If the parameter is polynomial, this gamma will be 0. And when it's not polynomial, D and R will be 0. And finally, we'll have C and P, the other 2 parameters to be chosen. So the chromosome practically is a structure, a linear structure with real values in number of 21 real values. The fitness function, of course, must be different than in the case of classification. And we consider the fitness function defined in this way. We have the square of the difference between the predicted and the real value. So mean square error, use like fitness function. And we apply the classical crossover and mutation operation in the case of the breeder genetic algorithm. So the crossover rule is given here. We obtain from X and Y another parameter, and alpha is a random variable that is uniform distributed. And also the mutation rule that is responsible for exploration. That use many parameters, S between -1 and 1, again randomly uniform chosen, and the value R and AI also in an interval 0,1, 0,5 using the precision of the machine on which we are working with. We denoted our new kernel, multiple kernel, OM kappa, optimal multiple kernel support vector regression, and use this kernel in order to predict the values from different Bursa Malaysia, KLC index, and Dow Jones Industrial Average Index from New York Stock Exchange, so some real values. The problem that we are working here is the problem of time series prediction. So practically, we predict a value xt plus p using a number of previous values that are determined by time delay and a dimension of our window. If we consider the results, we make a comparison of the results that we obtain in the case of our kernel with the results that are provided by other method. And in this case, SVR is practically a support vector regression classic with the RBF kernel. JEP and ALM are also 2 methods that we use in order to make the comparison. They are from totally different field of method. And we can see here that the results are better for all the metrics that we consider with respect to the other parameters, with respect to the other methods, sorry. So if we consider the graphical representation of our data, we have the blue, the real data, and the red that are the data from our model. We can see that in the training process, the trend is very okay. And here it's practically the prediction, also the trend, it's okay in the prediction. The problem that appears here is the percent between the training and testing data in the macro part of our algorithm. And we made a sensitive study to determine the best percent between training and testing data, and also the number of the kernels, as I said before. So if we consider the case of the simple kernels, we try our model for 4 kernels, 8 kernels in order to have a complete tree for our method, and also 1 kernel, so just 1 kernel, but built using our method. And here it's the classical RBF method that build the optimal kernel using a cross-validation, grid search cross-validation method. And we can see that there is a difference also in the case when we use only 1 kernel. So the characteristics are better. So the error is smaller in the case of our method than in the grid search cross-validation method. If we look here to the number of the kernel, we have 4 kernel, 8, and 1 kernel. We can see that in the case of 8 kernel, practically some of these values these metrics are better, but also the difference in computation is very high. So practically it's better to take the case of 4 kernels in order to obtain our multiple kernel. For the case of a ratio between training and testing data set, we saw that for more than 10% in evaluation data set, so we have training and validation in the macro level of our algorithm, so we cannot have more than 10, and the optimal value is practically 5. So we could predict well for 5% of data, knowing 95% before of our data. Practically this method was applied in the case of support vector machine and regression, but the idea can be generalized also in the case of other machine learning techniques, trying to construct multi-level optimization method and using hybrid algorithm in order to make the optimization of our values. Of course, as a future director of study, it's interesting to see how our model work or what is different in the case we change the fitness function. We have chosen the mean square error as fitness function, but we can change it, and it's interesting to see if the results change or not. So here are some articles. We started study these from 2010, but only in 2020 we published practically the part with the method for support vector regression. And I want to mention here my colleagues. I work with Florin Stoica and the other colleagues. We are working in our research center. So practically this was my presentation. Thank you for your attention. And if you have questions, I will be glad to answer.
Thank you very much. And interesting presentation about support vector machines and how to optimize the hyperparameters, a topic that is throughout machine learning, a very important topic. And this is a good focused presentation. I would like to ask if there are any questions from the audience in this moment. So we are now in the time of the coffee break. So I think we can have a bit of time for questions if there's some questions. I have at least one question, so but feel free to talk to Professor Simian. You can just unmute yourself and ask a question. Otherwise, I would start to have the question about support vector machines. I think it's a optimization-based machine learning technology in a way. As we have seen, you use meta heuristics. And my question is, if you see in the previous talks, there was a lot of talk about convolutional neural networks. How do you see these more classical mathematically motivated machine learning methods in contrast to these deep neural networks? What do you see as advantages and disadvantages?
So practically, the other one also, the deep learning methods are also a very, very strong mathematical base. If we think to the filters and the convolutions and the loss function that we choose between them. But of course, the difference is in the field of application. The convolutional neural networks are mostly oriented to the part of image processing, when we can just go through the image and apply filter and obtain the results. And in the other case, also by the cryptography, by example, there are some cases or articles in which practically the analysis of different kind of messages sent are just transformed in images, such that can apply convolutional neural network. So practically the dependence is on the field of application, and of course there is no free lunch theorem that give us the answer that it is not a better method for everything. So I don't know if this will be the future or with our conference. There were a lot of papers this year oriented onto explainable machine learning. So to see how the neuron or how the feedback in the network can be visualized, such that to see if indeed it is a valid result or not, especially for some fields that are very, very sensitive, I don't know, like law or something related to people. So where it's very important to see how the machine work or the weights were assigned.
Thank you for this answer. So I got the idea that the special architecture of convolutional networks is more suited to image processing and similar problems, like games that have some visual component like Go. Yeah, so I would, is there a question from audience? Otherwise, I have one more question, but I would give preference to other people from audience. Don't be shy. We have the opportunity to learn. I would like to ask about the swarm intelligence, which is another component that you mentioned in your talk. Something in my own research group that challenges us is how to select swarm intelligence algorithms, because there are now many different versions of them. What is your point of view? Is there clearly a favorite of yours, or how do you choose the type of meta heuristic for optimization?
No, I choose this time just based on the fact that we can associate practically our problem with a problem with task scheduling in the factories. Like we have 3 machines, our 3 operation, and we just want to assign a task to enter in or not in our kernel. And also this WASP model is very suitable for dynamic problems, some problems that are modifying times. Of course, I do not have the guarantee that there are not other other meta heuristics. I know them, but I did not use in this case. Could be the case that they improve, but anyway, in our case, the improvement was not very major using this algorithm. So practically changing more the operation was not improved. Or in some cases didn't improve a lot. I just closed the PowerPoint, but there they are the results also for different type of commutation operator and commutation operator together with WASP. And was not very much improvement or high improvement because of but was an interesting idea to use them.
So maybe there's also this idea of the portfolio that we saw in the first talk, that you should try maybe some different meta heuristics, look if they are very different, and just look at your problem and match the problem with a heuristic. Not all optimization problems are the same. Okay, thank you. So if there are not further questions, I would like to go to the to have a chance for everyone to fetch a coffee. We have a coffee break, a virtual coffee break. So normally it would be time to talk. So who wants to talk with us in the chat is also welcome, or with each other. And we will continue the program at sharp 1 o'clock and with session talks. Thank you, Professor Dana Simian, once more. Let's give also an applause to her.
Yeah, thank you very much.
Thank you.
Yeah, thank you. Somebody asked about presentations, PowerPoint presentations. Maybe can you give us your presentations to share with participants? I see this meeting chat asking about presentations.
Yeah, I have sent you my presentation, so you are free to.
Yes, of course. Yeah.
On the conference.
Sure. Yeah. Previously.
Setiawan, is it? What about your presentation? Is it possible to share it among the participants, or?
Yes, okay, no problem. I will send to you.
Thank you.
Thank you. Very good.
I will also send.
Okay. Thank you very much.
And please, to everyone, it will be nice if we don't share beyond the conference, because there's also sometimes problems with copyrighted materials, and not to bring our speakers into problems. Unless the speaker says it's okay, but I would normally say let's keep it within the conference. So we can maybe share it with the passwords that we share among the participants.
I suspect that Setiawan students asked about his presentation.
Okay.
Mostly. But I also interested, of course. It's very interesting report. Yeah.
So for the next session, it's actually, we can look if everybody is here. There's a talk by Professor Dosyn. You are here, and I am here. There's Professor Timchenko, Alexander Timchenko. Maybe joins later. And Karapetyan.
Timchenko, yeah, it's said Timchenko, Havrish, Hamula, Bogdan Kovalsky. I see Bogdan Kovalsky is present.
Yes.
It was
Hello.
third one.
Hello.
Hello. Yes, we are here.
Good. So we will use share screen and
It is Bogdan Havrish, yes? Or
No,
no?
but
Okay.
I'm introducing them.
Okay, no problem. But it will be at 13:30. First, Mykhailo, I'm second, and you third.
Okay, thank you.
We have very different reports, but it all connects with methods machine learning.
I think Yulian cannot join to present our paper. He has electricity big problems.
Vasil called and said that no electricity, and Vasil Litvin.
Oh, he can also not. Yes, I saw that he was not.
Yeah. Sorry, but many people cannot connect. After every strike, we have near a week needed to repair system.
You see, to build is much more difficult than to destroy.
Yeah. And as we talked before, the system is not prepared to such strikes. No reservation. We have some history with previous General Secretary of Communist Party, Nikolai Khrushchev. Forgot his name. Do you remember? Khrushchev, it was General Secretary of Soviet Union, Communist Party. That he flight only on plane Il-18. Il-18 plane can still fly with one engine. He possessed four engines, but even if 3 out of order, only one engine, and the plane Il-18 still will be safe. Therefore, Nikolai Khrushchev used this plane. We should have electrical network 4 times reserved.
All right. I think that is a good bridge to talk about complex networks, maybe. It will be the first session talk. But we are talking in networks or in other contexts. So shall we start? Maybe you can introduce this time.
Okay,
because
yes.
it's me to present.
Please, then. Now, first report on session talk. Mykhailo Emmerich, Yulian Kuryliak, and Dmytro Dosyn, sorry, me. Simulation of effects of targeted immunization on the peak number of infections in complex networks. Please.
Thank you. So the title was already mentioned and the authors. So Yulian Kuryliak could unfortunately not join due to the electricity problems, but he also substantially contributed to this report. I will give a brief introduction to the problem that we try to solve. It's the problem of epidemiological outbreak. It can be the outbreak of a biological virus, like in the COVID-19 example. It can also be related to a computer virus or that threatens a computer network. So we do an efficient and realistic simulation using the Gillespie algorithm. This was developed in a series of papers that we published previous to this paper. And in this paper, we are talking about strategies for immunization, targeted immunization. So which nodes to focus on to prevent the virus to spread across the network. And we want to, in particular, and as opposed to previous work, focus on the peak number of infections. That is, there's a certain time when the network is infected most, when most people have the virus, and then the hospitals have problems to give a proper treatment to the people. So we want to drop this peak number of infections. And also we have a small result on the visualization of the infection routes. Targeted immunization of a network. Let us consider a simple example. Let's see a network of contacts in a country, for instance, between cities via flights or between individuals via contacts. The problem is which node to immunize with priority to prevent the spread of the disease. One strategy could be biggest nodes first. That would be a naive strategy, saying the biggest nodes are maybe the biggest cities or the individuals with the most contacts. We focus first on them. And in this paper, we have strong evidence that this is by far not the best strategy. In fact, we should more look at the structure of the complex networks, and luckily there are some metrics that help us to summarize the importance of nodes in a single measure for each node of the network, the so-called eigenvalue centrality measure for matrices. Spreading phenomena in complex networks like epidemic outbreaks have been classified in the compartmental model by three different variations. One variation is that nodes can be susceptible in the beginning and can get infected by the virus. The second model is the SIS model, where we have the case as a susceptible mode gets infected, but it can recover. Then it is susceptible again to the virus. This is typical for the flu. SIR dynamics is something typical in the case of COVID-19. So nodes that are susceptible to the disease can become infected. And then when they recover from the infection, they become immune. And here it's also where we have our focus of this paper. We look at SIR dynamics and also a bit into SIS. There are papers on epidemics on complex networks that show that it's important to consider the structure of the complex network and not just assume that every node has the same number of contacts. Here we see a visualization of the infection route that we added to our simulation toolkit that is implemented in Python. We use continuous time Markov chain simulation, which is the most realistic we can get. It manages time not in discrete time steps, but in continuous intervals between two infections that occur in the network, and thereby we get a realistic simulation of the time durations between infections, and we can compute realistically the peak number of infections when it occurs in time and how big it will be. The simulation is, when you implement it in a naive way, very time consuming because you have an exponentially increasing in the number of node state space in this Markov process. On the other hand, you can reduce drastically the state space by some tricks that we summarize in various previous papers by efficient use of the GLSP algorithm for stochastic process simulation. And indeed, we have only a linear time for the computation of one iteration of the algorithm. This paper, however, is on using the simulation to find out what are good targeted immunization strategies to reduce the peak number of infections. And we focus on such strategies that give each node a value, a centrality value, and then we remove the nodes that have the highest centrality value, but we want to find out which centrality measures are the best for targeted immunization. So we can, for instance, focus on the local effect of a node in the network. For instance, how many contacts has a node? So big nodes first would be then the strategy. However, as I already said, this might be not the best strategy. We here also look at systemic centrality measures, and this means we look at the net effect of nodes on the network. So also at not only at direct neighbors of the nodes, but also neighbors and neighbors in the global structure of the network. An example that might make it very clear that this is important is a bridge node. Think of two big clusters or communities in the network. And there's one node that connects these two communities, a so-called bridge node. It might have only two contacts. So it has not it's not a very big node in that sense that it has only two contacts. On the other hand, it's of crucial importance of transferring the virus from one to the other community. And we can only see this by understanding the topology of the network. And luckily, also the metrics that we are going to look at here can see the global structure of the network because the way they are constructed. A classical or say recent often applied measure for SIS dynamics is the maximum eigenvalue of the adjacency matrix. And it has been more recently shown that the Hashimoto non-backtracking matrix needs to be used for the maximum eigenvalue when we have a SIR dynamic. I will briefly say what is a Hashimoto non-backtracking matrix, and of this we need to compute the eigen values and relate them to different nodes. The idea of the Hashimoto non-backtracking matrix is that we make a matrix that links adjacent links of the original network. So here we have one link of the original network and another link, and it's a matrix between links of the network, and we only link those links of the original network that do not backtrack. That means that do not go back to the original node in the second step. So here we would put a link of the Hashimoto non-backtracking matrix, whereas here we don't put a link. So there have been many recent papers that this is the right way to use to compute centrality metrics based on eigenvalues in the case of SIR dynamics, because in SIR dynamics, reinfection is not possible. A node that is infected once cannot be infected again, or in fact after recovery. So these cycles are not possible, and we can exclude them by this numerical trick. Why are these eigenvalues so important? So they are used for the measure of the centrality. Actually, we look, how does the eigenvalue of the matrix reduce when we remove the node? So it's the eigenvalue drop, if you are precise. And it has been shown that the maximum eigenvalue drop is inversely related to the epidemic threshold. The epidemic threshold is the contagiousness of the virus above which the virus will almost surely invade the entire network. Whereas when it is below, the contagiousness of the virus is below the epidemic threshold, it will almost surely evade it from the network. For peak number of infections, however, this measure might not be the best. So we did additional evaluations to see also which measure of centrality reduces most the maximum peak. And for this, we look at average shortest path lengths also, because in our data mining that we did on previous simulations, we found this also to be an interesting measure. The parameters of our simulations were as follows. We look at network models. The standard model, the Erdős-Rényi model, is a model where we have about the same number of contacts for each node. So it's a bit unrealistic, but it's in classical epidemiology, maybe the typical model that we assume each node has the same number of contacts, or even we assume a click. And then we have Barabasi-Albert model, which is a scale-free topology of a network. So we have different degrees of nodes represented in the network in a realistic way, that there are some nodes with a lot of contacts, and there are also many nodes with a small number of contacts, and it follows a so-called power law. Watts-Trogas is focusing on small world networks, that there is a low degree of separation between nodes, which is also known for realistic social networks. So Barabasi-Albert, Watts-Trogas are the more realistic assumptions about network topology. Ideally, we would use real network data of contacts, but this is very difficult to get. And so we use models of social networks that are as realistic as we can get. Network size here in our simulation is 200. The number of edges is about 400. We can go up to 20,000 node simulation in the moment using the efficient implementation of Gillespie. But then in these examples that I show, we use smaller communities. Time of being in the infected state is 10 days. So we use data of COVID-19, number of simulations, at least 50. So we can run again and again the simulation with different random numbers, and we will get an average behavior of the virus. We do immunization of no node as a null model, one node, just removing the most central node or the most important node based on the centrality, or the 5 nodes in a greedy manner. So first the most central node, and then so on. We can see in our results that on the Erdős-Rényi model, which is maybe the standard model in the published results on epidemiology, we don't have such a relatively not such a bad performance of the biggest node removal first strategy, so highest degree is a quite okay strategy, but we can postpone the peak a bit by using the eigenvalue here indicated by E-based strategies. So the more sophisticated strategies help us to gain more time to prepare for the peak. And now we come to the more realistic assumptions about topology of social networks that are in the Barabasi-Albert model represented here. And that is the main message of our paper. We find that by realistic simulation, we can understand that using the eigenvalue-based centralities leads to a drastically better immunization than and reduction of the peak, and also to a postponing of the peak as opposed to the biggest node first strategy. And the biggest node first strategy is almost as bad, even a bit worse in our simulations than doing nothing at all. So this is a really result that should be in practice considered. In small world networks that only focus on the small world property like Watts-Trogas, it's not such a strong effect. So the power law scale-free structure of networks makes a big difference here. And in such networks, we should use the more advanced metrics. It doesn't matter so much if we use adjacency or non-backtracking matrix. Maybe the risk of reinfection is not so high also in the adjacency matrix. Then we have done more results in the paper on different topologies that I will not detail, but they confirm the general trend that the strategy to immunize the biggest node is not the best strategy, but we should refer to more advanced metrics of node centrality that take into account the topology of the entire network. And we also looked at the probability that an invasion of the virus will happen at all. So sometimes in the simulations, it occurs that the virus is disappearing in an early stage. So we infect always one node in the network, and then we see what happens. And sometimes the virus disappears entirely. And here our results are not conclusive yet. Probably here also the eigenvalue-based metrics make a difference, but it is not so drastic than for the reduction of the peak. So our conclusions: immunization strategies can be efficiently tested on network models that are realistic to real social networks, and we challenge the state of the art in several key findings. And they are summarized here. I would like to emphasize the new findings, that is that the centrality measure makes a big difference. And I see that my time is almost up. So I want to leave it with this message: network topology matters, centrality measure also matters. Thank you very much for your attention.
Thank you. I'm afraid no time for questions. So
yes, you can. In the coffee break, we can have questions.
break, maybe anybody want to?
So we can move on then with your talk, Professor Dosyn.
Then let me do second report by myself. Dear colleagues, participants of the Montfort DS workshop, let me introduce you the work Domain Ontology Learning using Lean Grammar Parser and WordNet, fulfilled by me, Dmytro Dosyn, in cooperation with Dr. Yousef Daradkeh, Vira Kovalevych, Dr. Mykhailo Luchkevych, and Dr. Yaroslav. Textual information as knowledge can be recognized only in context. To add new knowledge, we need to take into account previous knowledge. Technically, it could be organized as a knowledge base and ontology as its basement. The process of filling the knowledge base is called knowledge markup or ontology population. In return, ontology learning methods are methods for automatic development of ontology structure. The previous stages of data integration in the field of text mining were based on the presenting of text document as a set of concepts, i.e. bag of words. Modern information retrieving paradigm was implemented as the existing digital indexing retrieval navigation resources like PubMed, Web of Science, CiteSeer, Scopus, Google Scholar, others. Evolution of approaches moves in direction to deeper analysis. From lexis and model of bag of words through semantics, using technologies like latent semantic analysis, up to pragmatics and intelligent information retrieval, which needs access to context kept in a knowledge base. Therefore, it is proposed to represent a text document as a message, which has often correspondent, author, and addressee. According to such representation, text contains only part of information needed to understand its content. The rest should be added from the knowledge base of the addressee. Different natural language processing tools could be used to analyze text documents, including so-called immediate constituent analysis and dependency analysis, examples of which you could see on previous slide here. Most of commonly used natural language processing tools have free license. We choose link grammar parser, which effectively parses syntactic dependencies between sentence words and phrases that helps to combine advantages of constituent analysis and dependency parsing. We call such obtained grammar syntactic relations between each word in sentence as meta-semantic relations, MSR. The general flowchart of data transformation for a separate relation extraction using link grammar parser and WordNet is presented on the slide. Parser distinguishes part of speech, part of sentence for each word in the sentence, and all possible versions of relation structure with corresponding probability. This data is used to extract logical predicates represented by its subject, object, and the relation between them. If the current word not have correspondent representation by a concept in our ontology, WordNet API is used to update taxonomy of concepts of the ontology. If all elements of the recognized predicate, subject, object, and relation are known, all predicate will be asserted to the knowledge base. Otherwise, if only part of elements is known, unknown one will be added to ontology. But the semantic relation plays the key role in the process of predicate recognition, although it is implicit and should be detected. Discovered by the link grammar parser, meta-semantic relation can help to solve this task. They serve as a sign of its presence. We had proposed to use a relation pattern in the form of set of descriptors, each consisting of distinguished concept name, its role, subject or object, and the kind of meta-semantic relation connected to this concept. The classical relation was used to recognize a type of semantic relation by the naive Bayes classifier. Feature vector set of pattern descriptors is considered statistically independent, and therefore probability of co-occurrence of in the features is considered equal to the product of the probabilities of independent appearance of each of the features. That is, we are looking for hypotheses about the present semantic relation H star. On the slide number 11, you can see the schema of recording in ontology the pattern of semantic relation as a set of descriptors. On the next slide, a block diagram of the algorithm of semantic relations weights updating during ontology learning. Thanks to sequential weighting of concepts, semantic and meta-semantic relations in ontology, all learning patterns are kept in a knowledge base. On the slide, there are tables with weighted parameters which are sequentially recorded in knowledge base during learning process. The method of ontology learning by natural language text using link grammar parser and WordNet API had been implemented in the application Crocus, which is abbreviation from cognition of relations over concepts using semantics. As an example of interactive using WordNet API, expert should choose one of meanings of the word thinking by selecting the right hyponym from the list proposed by WordNet. Another possibility analyzes the process of weighting the ontology during its learning by text. As an intermediate result of ontology learning, we can consider a histogram of semantic relations occurrence in a particular text corpus. Semantic relation recognition using naive Bayes classifier was checked on test sentences and showed high level of precision. And conclusion. As a result, in this study, the system of automated and semi-automated ontology learning from text had been developed using Carnegie Mellon Lean Grammar Parser and WordNet API. A combination of two different methods to distinguish semantic relation in natural language text sentences had been applied. Analysis of the sentence constituent trees by means of Lean Grammar Parser for explicit meta-semantic relation recognition and naive Bayes supervised learning for direct recognition semantic relations, which help of additional meta-semantic data obtained on the previous step. Developed approach was implemented in Java desktop application using WordNet API, OVL API, and Protege OVL API. Experimental results were compared to expert analysis and had shown good recognition reliability. Thank you for your attention. Maybe you have questions to me.
We have time, 3 minutes for questions.
Yeah. Sorry, maybe it's too fast speaking.
I think the presentation was clear. I wanted to ask about the Protege. How does it compare to other systems to manage the ontologies?
Protege is an editor and will help to control results using other tools. It's helpful and has own API, and it uses it also to creation similar systems. It's right. Java is open source and very useful.
And this naive Bayes classifier, can it be replaced by other machine learning technologies? Or is it?
Yeah, it's possible. I don't know. It could be tried and compared to existing method, but it's quite simple and natural to use naive Bayes classifier.
So also more explainable or transparent, interpretable, let's say.
Yeah, yeah.
Okay, thank you very much for the talk. If there are no more questions, I would lead to the next talk. So Bogdan Kovalevych.
Yes. All right. Hello, good day. I would like to present the results of our research. The topic is VAP in speech coder based on Velvet transform. Unfortunately, according to technical issues and electricity issues, ladies and gentlemen, couldn't be present here. That's why we really apologize, and please allow us to present the presentation on video. Thank you very much for understanding. Okay, and we will try to do that.
Okay.
Hello, today I want to present you the results of the research called VAD in speech culture based on wavelet transform done by Alexander Timchenko, Bogdana Havrish, Orest Hamula, and Bogdan Kowalski. Today we will cover the overview in the basic requirements of the VAD systems, determination of the main parameter of the telephone signal for the operation on the VAD.
I'm sorry, please let us know, do you hear well the presentation? Is
Yes.
everything okay? Thank you very much. Let's continue. 1 second.
The system, the proposed mechanisms, schemas, and much more. So the use of VAD provides a possibility to pre-process the speech signal before transferring it to the encoder. In the first approximation, the following types of signal fragments can be selected. So focalized, non-focalized, transitional, and paused. When the transmission speech in digital form, that is in the form of a sequence of numbers, each type of signal with the same duration and the same quality requires a different number of bits for encoding and transmission. The simplest example of the VAD mechanism is illustrated in the figure 1, which you can see on the slide. The speech signal enters the input of the comparison device in which the amplitude is measured and compared with the given threshold value at some selected time intervals. There is a VAD method based on the power level calculated in each speech segment. This algorithm is more complicated in comparison to the previous one, as it requires the calculation of the power of the running fragment and the determination of the ratio. The formula you can see on the slide also. So if the value is less than the specified threshold, then as in the previous case, this will determine the need to discard the packet. The third solution is when the GSM standard adopts the VAD scheme or the processing in the frequency domain. Work is based on the difference between the spectral characteristics of speech and noise. Background noise is assumed to be stationary over a relatively long period of time, and its spectrum slowly changes over time. VAD determines the spectral deviation of the input action from the background noise spectrum. The VAD detector must be sensitive and fast to avoid loss of word onsets when transitioning from pause to an active speech fragment, and at the same time, the VAD detector must not be triggered by the background noise. The telephone conversation between two consumers is usually accompanied by the large number of emotional pauses, and taking into account the delays expertized by SpeechPact in VoIP network, pauses and added to natural speech to wait for an answer. For this study, it can be assumed that the distribution of instantaneous value of speech signals corresponds to the exponential law. The details of the formula you can see on the slide. Also, the influence of pauses is taken into account using the activity of coefficient K of the signal source. It is equal to the ratio of the time during which the signal level at its output exceeds the set threshold value to the total conversion time. It was extremely experimentally established that the quality of the reception of the TEF signal is still acceptable. The average interference power Therefore, the required immunity of the telephone signal should be calculated as on the formula you see the first on this slide, but the dynamic range of the T signal calculated as the ratio of the maximum power to the average power of the permissible interference is equal to the second formula you can see. And when we evaluating the potential information volume, it is necessary to take into account the activity coefficient of the signal source. So in the VAD structure, the noise level and the output of the encoder is equalized and its threshold is set, adapting the encoder in relation to the value of the input speech signal. Analogs to this solution, noise equalization can be replaced by maintaining the input signal level within certain limits while simultaneously fixing the noise level. That is, such a scheme becomes adaptive to the signal level. The implementation of such principle is simple, both in analog and digital form. Its structure corresponds to the circuit with automatic gain control, which means it has the ability to adapt almost instantly to the level of the input signal. So the scheme of evaluating the quality of the speech signal that we talked before is now displayed on your screens. The VAD performance study also can be observed here. It includes of input signal, output signal, and output signal from the different segment power. The MCE of the output signal is shown here in 3 different versions. First one is at the level of 1/128, the second of 1/16, and the third one is VAD at the general file level. And the study of the work of the VAD compression ratio is displayed here. And in the last slide, you can see the comparison of VAD method by compression ratio by level and by power. So the proposed VAD operation algorithm is highly efficient, provides a sufficiently high compression ratio. When evaluating the quality of VAD work according to the SKD criterion and when listening to processed speech samples, it is possible to indicate the maximum value of rejected quantization levels and the value of the adaptive power threshold at which the number of zeros segments practically does not affect the quality of the restored speech signal. Therefore, during the conducted research, slightly deviation of the quality of speech signal reproduction are observed when discarding up to 8 quantization levels of 128, or when a power threshold of 0.3% of the maximum signal level in the segment is set. Accordingly, the achieved compression ratio is 19.35 and 15.6. So thank you for your attention.
Thank you very much.
Thank you very much for your attention, and we wish you a good day. Thank you.
Without questions, answering questions?
I can tell your questions if you have any questions to the team, to ladies and gentlemen. Please feel free to ask if you have, and I hope they will answer soon.
Thank you.
Mm-hmm. Okay. this method could be patented. Your approach, you maybe want to organize as patent.
I will ask them. Thank you for your question. Anything else?
Okay.
I would suggest to use optimization to even some advanced optimization strategies maybe can be tried to further improve performance, like hyperparameter optimization. So I'm not sure if this is applicable, but I would maybe it further improves the performance.
Okay, thank you for your comments.
Okay, so thank you for presenting the presentation of this talk and joining us. Then for the next speaker, it is
Who will be reporter?
I'm not sure if he's here.
Yevhen Fedorov.
He's here. He's here. Hello, Igor Fedorov. Nice to meet you. You can share your screen and give us your report.
Presentation. Yeah. Так. Yeah. Так. PowerPoint. Сейчас. Share.
Take your time. We have a bit. We are good at the time. So we should also start at 45, if I see. So we have still 2 minutes for people.
Creating a neural network and safe solution human-based meta-heuristic methods of solving the travel and salesman problem.
Maybe full screen. F5. Very good.
Object, subject, and goal of the research. The object of the research, the process of finding solutions to optimize problems. The subject of the research methods of finding a quasi-optimal solution based on meta-heuristics and artificial neural networks. The goal to increase the efficiency of a quasi-optimal solution search to the travel and salesman problem using the neural networks and meta-heuristics methods. To achieve this goal, it is necessary to solve the following tasks. Create an optimization method on an artificial neural network. Create an optimization method based on single solution human-based meta-heuristic. Conduct a quantitative study of the proposed optimization method. So, then video initialization. Training iteration number, initialization evolve network weights. For that point with coordinates is located on the surface of a dimensional sphere of a radius. Is that a vertex coordinates specified initial shortest distance. The maximum number of iteration is calculation of the distance to all neurons of the network. The distance from the neuron to each neuron is determined by the formula. Calculation of the shortest distance and selection of the neuron with the shortest distance. The smallest distance is calculated, and the when a neuron is selected for which the distance is the shortest. Setting the weights of the neuron and its neighbors based on the calculation of the center of mass of the cluster. Where as is the topological neighborhood function, what sigma the effective width of the topological neighborhood decreases with time. Sigma 0 initial effective with of the topological neighborhood. Theta start temperature, beta cooling rate. Checking the computation condition of training. Calculating the distances to all neurons in the network. Selecting the neuron with the shortest distance. The result is a vector of top rank base. Iteration third. Integration, setting the maximum number of iterations, the maximum number of local search iterations, in order that a vertex is specified as the edge weight matrix, specifying the cost function, goal function, set by randomly ordering the set the best vertex vector, local search based on to opt, to vertex setting the first and the two and randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied. Based on the vector, the vector is created. If the condition, then otherwise iteration number performing a perturbation generation of a solution from a solution based on for opt. Three vertices are randomly selected from the vector based on the vector. The vector is created, local search based on to opt, two vertices, the first and the second are randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied based on the vector. The vector is created, determine the best solution and condition for dominating the search for a solution. The results is search with variable neighborhoods. Initialization, setting the maximum number of iterations, the maximum number of local search iterations, in order set of vertex is specified and the edge weight matrix, specifying the post function or goal function. Is set by randomly ordering the set the best vertex vector. Iteration number, neighborhood size, create a neighborhood solutions based on two opt. Two vertex, the first and the second are randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied based on the vector. The vector is created. Vector is randomly selected from the neighborhood, local search based on to opt, two vertex. The first and the second are randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied. Based on the vector is created. Determine the best solution, determine the neighborhood size, conditions determining the search for a solution. The result is greedy, randomized, adaptive search. Initialization, setting the gradient parameter alpha or a greedy randomized procedure, setting the maximum number of iterations, the maximum number of local search iterations, in order set of vertex is specified, and the edge weight matrix specifying the cost function set by randomly ordering the set the best vertex vector, iteration number, running a greedy randomized procedure from a set of vertex, a vertex is randomly selected. The initialization of the search of forbidden vertex is number of forbidden vertices, creating a set of allowed vertices in isolation of the set of restricted candidates, vertex number from a set of vertices randomly selected. Local search based on two vertices, the first and the second, are randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied. Based on the vector is created, determines the best solution condition for terminating the search for a solution. The result is guided local search. Initialization, setting the scaling factor of the penalty function, setting the maximum number of iterations, the maximum number of local search iterations, vertex vector length, in order to set a vertex is specified, and the edge weight matrix, specifying the cost function, specifying the penalty function, specifying an extended cost function, setting the utility function, set by randomly ordered, set the best vertex vector. The current solution is set, penalties are initialized, iteration number, a local search based on two vertex, the first and the second are randomly selected from the X, and the selection of this vertex continues until the condition is satisfied. Based on the vector, the vector is created, the penalties are modified, determine the best solution, condition for terminating the search for a solution. The result is parallel optimization meta-heuristic under special intensification conditions. Initialization, setting the maximum number of nearest components, the maximum number of iterations, the maximum number of search iterations with taboos, the size of neighborhood solution length, maximum length of the taboo list. An ordered set of vertex is specified in the edge weight matrix, specifying the cost function, set by randomly ordering the set, the best vertex vector. The current solution is set. Initialization of the set of taboo vertex, iteration number. The number or the component is randomly selected and creating a set of vertex number. All vertices are sorted by proximity to the vertex. And the top closest vertex are selected from the which a set is created. Optimization procedure use of search with prohibitions. Inserting the taboo list, search iteration number with taboos, creating a neighborhood solution based on top. Two vertex, the first and the second are randomly selected from the vector, and the selection of this vertex continues until the condition is satisfied. Based on the vector is created. A pair of taboo edges is created for the vertex vector. From neighborhood, a solution with the lowest price is selected. A pair of edges is placed at the start of the taboo list. If conditions, then a pair of edges that were taboo early is punched from the end of the taboo list. Determine the best solution. Stronger version is possible. A weaker version is possible. A condition for terminating the search for solution. The result is an alien temperature decrease function is the initial numbers is 106 and the current coefficient is effective with a topological neighborhood. What is the temperature? The current coefficient. Comparison of the proposed soft training methods with the existing one based on the criteria of time and the path length. Criteria height, proposed method, existing method. Comparison of proposed single solution human-based meta-heuristics with taboo search methods.
Meta-heuristic, iterative local search, search with a variable neighborhood, greedy randomized adaptive search, guided the local search, marginal optimization, meta-heuristic under spectral intensification conditions, tabu search, database Berlin 52 was this database, the optimal mass length is conclusions. The urgent task of increasing the efficiency of methods for solving the travel assessment problem was undertaken by creating methods based on artificial neural networks and single solution human-based meta-heuristics. The proposed modification of the learning method for a cell organization feature map uses certain ways of the neuron and its neighborhood based on the calculation of the center gravity that allows for accelerate the training of this neural network during parallelization in case of the GPU use. The effective dynamic with of the topological neighborhood for calculating the topological neighborhood function, which allows to explore the entire search space at the initial iterations and make the search directed at the final iterations. This ensures high accuracy of the search through this neural network. A modification of single solution human-based meta-heuristic is proposed that allows potential integer solution and the use to permutation in the case of a local search neighborhood creation and for permutation in the case of a global search, which allows adapting this meta-heuristic to solve the travel assessment problem. The proposed methods make it possible to expand the scope of application of this feature map and the single solution human-based meta-heuristic, which is confirmed by the adaptation to the travel assessment problem and contributes to improve efficiency of intelligent computation system. Prospects for further research study of the implementation of the proposed method on a broad class of artificial intelligence problem. Thank you for attention.
Thank you very much for your report. Maybe somebody will ask a question to reporter.
I have a question about the parameters. What parameters this algorithm has and how do you optimally set them?
Effective with a topological neighborhood and inland temperature would decrease function.
So you have designed experiments to set the optimal parameters. Okay, but they have...
The initial temperature is 106 and what cooling Kevin.
So my question is more, can you tune these parameters and see what is the potential of this method when you set them to the right value? Or did you tune them? So I was wondering if you can further improve by tuning parameters. Otherwise.
Automatic adaptation.
Okay. Thank you. It was interesting talk on a challenging optimization problem. Quite many techniques combined in this algorithm. Thank you.
Thank you.
We going to next. Can I claim the next reporter. Vladislav Shlyanin, Yuri Gordienko, Sergei Sirenko. Who is present now? No one present, yeah.
Then we should.
Maybe we look for this time, look for video from.
Yeah, let's play the presentation, yes.
Mhm.
It's linked in the program.
I will try to share screen with this presentation. Yeah, it will be number 4, yeah? Creating neural networks. Dmytro 5, yeah. Prediction.
It's number 5.
Number 5, yes. One moment. Sorry, I will now share screen. One moment. You can see, yes?
Yes.
Audio also listen.
No, you need to share also audio. So you have to.
Yeah, the same case. One moment. When I share, I should.
There's a check, yes.
Sorry. Share sound and video. And start.
Kyiv Polytechnic Institute. Today I am presenting my paper, Link Prediction Method in Graph Objects by Autoencoding in Graph Neural Networks. So, the basis of this research is a link prediction task, which can be defined as predicting whether two given nodes in a graph may or may not have a link between each other. It is a pretty common task for a graph structure data. Most frequently it is used in the context of social networks or recommender systems. Traditionally it is based on heuristic methods such as Katz index and others. But the problem is that it is not applicable for all datasets. In some cases, nodes may have completely different properties and still have a link. Also, it is worth noting that link prediction based on graph autoencoders is underrepresented in existing researches. The main aim is to increase link prediction accuracy in graph neural networks, utilizing graph autoencoder architecture. To reach this aim, following tasks were planned: preparing datasets suitable for GNN, applying GNN with graph autoencoders and variation graph autoencoder architecture, comparing graph autoencoder and variation graph autoencoder performance on link prediction task, and exploring GNN performance differences based on graph convolutional network configuration within model. For the purpose of this research, customized dataset was constructed, which consists of legal acts adopted by Ukrainian parliament and Ukrainian government. It contains more than 68,000 acts and more than 89,000 links between them. This data can be represented as a directed graph, in which nodes are acts and edges of this graph are links between said legal acts. For the purpose of this research, 4 different models were created, and all the models implement graph autoencoder architecture. This architecture consists of a decoder and encoder. The encoder takes data from input and transforms it into a lower dimensional embedding Z. Then the decoder takes this lower dimensional embedding and reconstructs the original input. Usually, graph convolutional networks are used as an encoder, and dot product is used as a decoder. Also, a portion of models implement variational graph autoencoder architecture. In variational graph autoencoder based model, encoders output mean and variance vectors, which are converted to Z embeddings. And encoders of regular graph autoencoder models output this embedding directly. So here on this slide you can see 2 models which are implementing graph autoencoder architecture. The first model has 2 graph convolutional networks and the ReLU function. The second one has only a single graph convolutional network, which is why it is called a linear model, linear GCN, and this one is just GCN model. And on this slide you can see 2 models which are implementing variational graph autoencoder architecture. This one has 2 graph convolutional networks and the ReLU function, and this one has a single graph convolutional networks. And both of these models output mean and variance vectors on the encoder parts, and these vectors are transformed into a Z embedding. And of course this model is called VLGCN model because it is variational graph autoencoder model and it is linear since having a single graph convolutional network. And this is a VGCN model. And each model's training process was performed 10 times to calculate mean performance and standard deviation. Each training iteration was done with a randomly generated seed, and all models were reset each time. And here on this slide you can see the results. As you can see, GCN model, the one with 2 graph convolutional networks, and the model which is implementing graph autoencoder architecture is the most efficient. However, the performance differences between all the models is not that significant. For instance, mean area under the curves curve of GCN model, the most performant model, and LGCN model, the least performant model, is only 2%. And also here you can see the log of all the models combined, and these curves are almost overlapping. Also, it is worth noting that models with singular GCN perform observably worse than models with 2 GCNs. And the difference between graph autoencoder models and variational graph autoencoder based models is insignificant. However, variational models perform slightly worse. The cause of such an effect may be the nature of the specific dataset upon which these models were evaluated. So, experimental results lead to the conclusion that the amount of GCNs may be more significant in some cases than the difference between graph autoencoder and variational graph autoencoder architectures. By experimenting with the configuration of GCN layers, prediction performance may be further improved. For example, the other further improvements of the proposed approach can be implemented due to hybridization of graph, convolutional, variational, and other network components. Also, it is worth mentioning that this work was partially supported by knowledge at the tip of your fingers, clinical knowledge for humanity, project funded from the European Union's Horizon 2020 Research and Innovation Program. Thank you for your attention.
Sorry.
So
Okay.
he's not here. So if you have questions, we can maybe he will join to a later break, and you can then ask questions. Otherwise, you find in the paper also the contact information.
And you can comment on the YouTube. All
Right,
these
this is
posts are there. Yeah.
so we will wait a moment because the next talk is scheduled for 15 in Eastern European time.
The reporter is present, as I see. He can share.
Yes, I'm here. I will.
Ah, yeah. Hello.
Hello.
Yevseyeva.
Mm-hmm.
Shall we keep the time schedule or shall we start earlier? What?
I don't know. It's a few minutes. You can.
I think not many people have recently joined the session, so we are pretty constant. So let's maybe start, or maybe some of your co-authors still want to join. We can wait. It's just 4 minutes.
We have from have from.
Because there might be someone who wants to precisely to this time join in to see this talk, and then it would be not nice to start earlier. But maybe you can already share the screen that we. Yes.
It's a report from Kyiv. Lviv.
No, it's from Estonia.
Estonia. Sound. Repeat, please. Problem with connection.
Yes. Do you hear me or not?
We can hear you, but previously it was not a good connection.
Some interruptions.
Not.
Now it's.
Lviv Polytechnic. Okay.
No.
We listen only no. But what no?
Do you hear do you see my slides?
Yes, we see your slides, and you can also start presenting.
Please start.
I'm sorry. Authentic software. After a few researches on speech recognition, speech generation, and speech-related tasks, we have published a few scientific papers. We have been presented in MOMLET 2020 as well. Go more to be researched in this. The main struggle here is there's a lot of models. There's a lot of pipelines, how to train model, how to but there's not a lot end-to-end production into business to solve business tasks. And as a related model for speech recognition toolkit to train
I'm afraid that we
and
have
serve
problem
model and
with
speech percent,
recognition.
but I'm sorry, maybe my connection is not.
Maybe we can play the video and then you can answer questions.
Yeah, it's better. Once again, I will share my screen, and I will
Not very good.
Mm-hmm. We can you can stay for questions and then we can.
Sure, thank you, Mykhailo.
Mm-hmm.
It will be which one? 6-1, yeah.
Yes.
One moment. You can see screen.
Yes.
My name is Yusef, and today I'm going to present our work, prototyping methodology of end-to-end speech analytics software. We will start from our previous publications. We have highlight few of them: technique comparison for natural language processing, sentence segmentation from.
But I will interrupt after 15 of this video because it's 23 minutes long.
Formatted text, analysis for automatic speech recognition, pipeline for training, automated speech recognition, safety of speech information, and speech emotion recognition transferability. All these previous works work as preceding to this building of prototype that organizations can use in production in order to deliver value to the customer. As of prototype, there's few frameworks in the market that works for speech recognition. There's few approaches how to build it, but there is not comprehensive approach and recommendation and experiments on how to build end-to-end business software based on models of speech recognition, emotion recognition, NLP frameworks, etc. Now it's independent modules, and our main goal of this paper is to describe and make a prototype for end-to-end solution that can be put into organizations' production mode and can be used to deliver value to end customer, I mean business, organizations, etc. Our related works that we see is, let's start with NEMO. NEMO is, let me choose laser, NEMO. This is a toolkit for building AI applications. And this toolkit does not provide any storage, any database. It's interface toolkit basically, where you can upload or choose an audio, and result will be either transcription or emotion. It is very flexible toolkit. It can do a lot of speech recognition and NLP tasks, but it is not end-to-end in terms of business value. It is only NLP and speech tasks. That is not enough from our opinion for business customers. Another one is ESPNet. ESPNet is end-to-end speech processing toolkit, where you can upload or train your own model, fine-tune speech recognition model, add some specific task based on the speech, like speech emotion recognition, dearization, etc. And then you can use this toolkit once again to make very small, narrow tasks of speech recognition, for example. And the third one, as we can see, is called the speech recognition toolkit. Once again, it's only for minor blocks or tasks like speech recognition, diarization, emotion recognition, embedding, etc. So all of these three frameworks limited only to speech-related tasks or NLP tasks, and they do not have any storage, they do not have any queuing logic, any clustering, etc., etc. So it's only building block where what organization can use to build this software. So we have defined few inputs, few requirements for our prototyping. It should be loose coupling. It should be pipeline flexible in pipeline term and interoperability. Let's start from the pipeline flexibility because loose coupling we will be defined later. Next slide. So pipeline flexibility means that we do not know exactly which task will the business customer need at the very end of implementation. Hence, we need to make it as module architecture as possible. You need to add one more task, not a problem. You do not need to change all other components. It should be like microservices. So it should be flexible, it should be easy, it should not change anything of already existed in your prototype or your software solution. Interoperability. That's not a separate environment, and software works in real time, like software environment. Organizations have CRMs, BI system, a lot of data lakes system, a lot of systems that these software should be integrated into. That's not an independent software. It works with contact center solution, with CRM solution, with telephony solution, etc. So it should be interoperable. Words into number to convert, and punctuation. That's a minimum number of tasks that need to be fulfilled for business case. And for version 1, we started with version 1, and then we will go to version 2. We started with very simple architecture and algorithm. We input audio stream within API post method, HTTP post method. We return result ID immediately. So we queue this and then started to recognize audio stream, post-processing task like punctuation, like diarization, normalization, and storing result into the DB, and that's it. And the customer can, after this finished, can request get by ID, result ID, get all text results. How it works on component level, we have API and backend side for prototype. We in paper have more detailed framework selection for backend and API. This is a fast API framework, very flexible and very easy to be built API on. We have ASR level, we have post-processing level, and we have database. So when you input audio file, backend gives you through API, gives you result ID that you can use in future to request your data. And then after this, close the connection and start in processing of your audio. First is speech recognition level, then normalization, punctuation, diarization, and then store all the results to the backend. So quite simple logic. Version 1, we will go to limitations of this version. There's a lot of limitations of this version 1, and that's why we implemented version 2. I will start with algorithm, and then we'll go to the component level. First of all, in version 2, we decide either these by the flag that we can receive through API from the customer, either this real time or non-real time. And if it is real time, we recognize and return result immediately at the same to the same channel. Usually for prototype, we decided to go with WebSocket simplest for real time. And if it is not real time, it's a simple asynchronous API, HTTP REST API. So we once again return to the customer result ID, but instead of immediately recognizing audio file as in version 1, we create QA task for recognition and post-processing. The main limitation of version 1, I will return to version 1, was without queuing algorithm, we receive a file and we immediately start to recognize. And if something inside of recognition process as of now, it will degrade performance significantly. So in version 2, we added this layer of queuing. And if recognizer is not ready, I mean, like doesn't work, that's one scenario, or overloaded is another scenario, then it wait. And when recognizer is ready, the recognizer took this QA task and start recognizing audio file, and after that running post-processing, and after that storing to database. And on component level, it is still relatively simple, a little bit more comprehensive, but simple still. We have real-time connection, WebSocket through HTTP, and we have asynchronous non-real-time for REST API. And when you send a file, first of all, backend put it into the queue, and then when the recognizer's ready, they took from the queue and recognize and put back like I'm done. And then post-processing level, once again, when they're ready, each of them, they took from the queue and then return to the queue, I'm done, and result. And we also add indexing. We'll go a little bit, and in the end we store everything to database. It is much more reliable, much more like ready for production. We also add instant search indexing layer in order to deliver results through backend API even faster, and basically as it's written for instant search for the content.
We should stop and ready for questions to reporter. If anybody have questions. Maybe Johan can say maybe last maybe subsumption, something about.
So main goal was to experiment and to find way how to combine these blocks to be very simple, yet very very customizable, flexible, and to deliver a lot of load. So each researcher, when trains the model, can serve with the same prototype this model into any business software production. That was the main idea of these experiments, how to find these algorithms and how to combine these blocks. We still have some limitations, which is highlighted in the paper, but this second version of prototype can be used in business software, even in production, for to serve any speech-related models into production.
Okay, thank you for the clarification. So it is, when I see this talk, it's very important to have clear performance metrics to understand how well the system works. So
yes, in paper we highlighted some within 4 GPUs. This second version of prototype can handle 45,000 of hours of real-time audio. So you can stream 45,000. So it's like very reliable and very fast with this simple logic.
okay, so how can you assess 45,000 hours? I mean, how do you understand that it can do so long?
Yes, we just stream in parallel
Okay.
few thousand of requests to this asynchronous API, and then calculate when it finished and deliver results.
Sounds impressive. Thank you.
Thank you, Mykhailo.
So, thanks again for the talk. And if there are questions from the audience, please say now. We have actually a lunch break coming up. It's a bit longer break, and then at 15:30 or 16:30, depending on the time zone, we will have the next session. And it will be another long session followed by a very short last talk session. So please reconnect or have a lunch break if you can. And I will do so now. So I will be back for the next session.
Yeah.
Thank you. See you.
Thank you.
Що, Сашко?
Година перерви. Через годину з'єднуємося знову.
Значить, не по тому часу йде зараз конференція, що прийшла?
По європейському часу.
А по європейському часу, то плюс година.
Так, плюс година.
Я зрозумів.
Central European Time. 2:30 по.
Окей.
Thanks. Чекаємо вас за годину. See you in an hour.